Sebelum acara dimulai, kami akan menyampaikan petunjuk keselamatan pada keadaan darurat yang berlaku di ruang sidang Departemen Fisika. Saat ini hadirin sekalian sedang berada di ruang sidang lantai 2 Departemen Fisika, Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Gadjah Mada.
Good morning and welcome to the conference room of the Department of Physics, Faculty of Mathematics and Natural Sciences, Gadjah Mada University. Before the event begins, we will deliver the safety briefing for the conference room of the Department of Physics, Faculty of Mathematics and Natural Sciences, Gadjah Mada University. At this moment, all audiences are in the conference room on the second floor of the Department of Physics, Faculty of Mathematics and Natural Sciences, Gadjah Mada University.
Ruangan ini dilengkapi dengan satu pintu utama yang berada pada sisi timur yang berfungsi sebagai pintu masuk dan keluar ruangan. Fasilitas kamar kecil berada di sisi utara dan selatan ruangan ini. Untuk menuju toilet, Anda dapat keluar melalui pintu utama kemudian berjalan ke arah kanan atau kiri menuju bagian ujung.
This room is equipped with a main door located on the east side, which serve as both the entrance and exit. Restroom facilities are located on the north and south sides of this room. To reach the restroom, you can exit through the main door and walk to the right or left towards the end of the hall.
Ruangan ini dilengkapi dengan fasilitas keadaan darurat berupa alat pemadam api ringan atau APAR yang terletak di dalam ruangan. Sehingga para hadirin dilarang untuk merokok di ruangan ini selama acara berlangsung.
This room is equipped with emergency facilities, including a fire extinguisher located inside this room and a smoke detector installed in the ceiling. Therefore, audiences are prohibited from smoking in this room during the event.
Titik kumpul terdekat berada di halaman depan gedung ini yang digunakan untuk berkumpul ketika terjadi keadaan darurat. Para hadirin dapat berjalan dengan menuruni tangga hingga lantai dasar dan keluar gedung.
The nearest assembly point is located in the front yard of this building, which is used for gathering in case of an emergency. Audiences can walk down to the stairs to the ground floor and exit the building.
Hari ini kami tidak melakukan simulasi atau latihan keselamatan keadaan darurat. Apabila hadirin sekalian mendengar bunyi alarm atau lonceng secara terus-menerus, maka itu adalah tanda dari keadaan darurat yang sebenarnya.
Today, we are not conducting any emergency simulation or safety drill. If audiences hear a continuous alarm or bell, it indicates an actual emergency situation.
Anda kami mohon untuk tidak panik, tetap tenang, dan segeralah keluar melalui pintu keluar terdekat. Bagi yang menggunakan alas dengan hak tinggi, harap dilepas, kemudian turun melalui tangga dan ikuti jalur evakuasi menuju titik kumpul utama di halaman depan gedung. Kemudian ikutilah arahan lebih lanjut dari petugas kami.
We kindly ask you to calm and exit through the nearest exit. For those wearing high heel shoes, please remove them, proceed down the stairs, follow the evacuation route to the main assembly point in the front yard of the building, and then follow further instruction from our staff.
Demikianlah petunjuk keselamatan pada keadaan darurat yang berlaku di ruang sidang Departemen Fisika, Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Gadjah Mada.
Thank you for your attention. Selamat pagi, hadirin yang berbahagia.
Yang terhormat, Dr. Renat Wiwit Suryanto, SSI MSI, selaku Wakil Bidang Penelitian dan Pengabdian kepada Masyarakat.
Respectable to Mr. Sri Sadono as Exploration Geophysics Advisor from Pertamina Hulu Energi.
Respectable to Mrs. Yong as Regional Marketing and Operational Manager for Asia Pacific PGP Offshore, PGP CNPC.
Respectable to Mr. Chen as Regional Head of BGP Processing Southeast Asia.
Serta hadirin yang berbahagia.
Assalamualaikum warahmatullahi wabarakatuh.
Shalom, Om Swastiastu, Namo Buddhaya.
Salam sejahtera dan salam kebajikan untuk kita semua.
Selamat datang di Kuliah Umum, Akuisisi dan Pengelolaan Data Marine Seismic untuk Eksplorasi Bawah Laut Indonesia. Boleh tepuk tangan dong, teman-teman semuanya.
Dari judul yang diangkat, jadi nggak sabar nih apa pemateri yang akan kita bawa hari ini.
Oke, tapi sebelum itu, perkenankan kami untuk memperkenalkan diri. Perkenalkan, saya Aisyah dan rekan saya.
Saya Luna akan membantu acara ini beberapa waktu ke depan.
Nah, mari kita buka acara pada pagi hari ini dengan mendengarkan sambutan dari Wakil Bidang Penelitian dan Pengabdian kepada Masyarakat kepada Dr. Ernat Wiwit Suryanto, MSI. SSI, kami persilahkan.
Good morning everyone. Thank you very much, Mas Robi. Ini namanya Mas Robi. He's actually Sundanese now. Ini orang Sunda nih. Mas Dono, ini terima kasih dari pembicaraan beberapa bulan yang lalu. Akhirnya pagi ini kita dapat menyelenggarakan guest lecture ya, yang luar biasa. Terima kasih sekali Mas Dono dan juga Mas Ijul yang sudah mengkoordinir kegiatan ini untuk adik-adik mahasiswa, dan saya ucapkan selamat ya buat adik-adik, Anda terpilih ya secara dari kemauan sendiri untuk mengikuti kegiatan pada pagi hari ini, karena ini menurut saya sangat penting. Dari perjalanan saya menjadi dosen selama mungkin hampir lebih dari 20 tahun, saya menyadari bahwa kuliah itu nggak begitu penting sebetulnya, tapi justru yang penting itu adalah Anda mendapat experience langsung dari orang-orang yang hadir di dalam acara guest lecture. Pengalaman saya dulu juga senang sekali kalau ada acara seperti ini ya, tapi kemudian lama-lama kan saya tuh pernah ingat waktu S3 itu pernah dicari profesor saya gara-gara saya males datang di acara seperti ini, karena kalau di luar negeri kan mereka sering mengambil expert seperti ini, tapi bidangnya kan beda-beda. Nah kadang kalau bukan bidang geofisika saya sering endo gitu ya, sering berusaha ngelim. Nah suatu mana Wiwit dicari, ditarik suruh ikut. Dia bilang jangan melihat apa yang dia mungkin kontennya mungkin nggak berhubungan langsung dengan kita ya. Tapi saya baru menyadari, keren juga nih orang astrofisik gambar image gitu ya, galaksi gitu keren banget gitu. Jadi itu menginspirasi saya, kalau bikin gambar berarti harus yang keren. Jadi banyak sekali hal-hal yang Anda akan dapatkan ya. Meskipun seolah kalau Anda mungkin melihat temanya itu tidak sesuai, tapi saya yakin ada banyak sekali hal-hal yang bisa Anda ambil manfaatnya dari situ. Ya. Jadi bahkan pas misalnya ada kuliah pun, bukan wakil dekan akademik ya, saya bidangnya wakil dekan riset, jadi ya saya mendorong riset. Kalau pas kuliah ada tamu keren, Anda ngelimpe saja. Nggak apa kan 75% boleh, Anda nggak masuk 25% boleh kan dari aturan. Karena ini jauh lebih penting, benar banget. Ya. Kemudian apa yang Anda dapatkan di sini nanti Anda akan banyak melihat, tidak hanya materinya saja ya, hubungan dengan geofisika kan ini luar biasa ini. Pak Robi ini nanti beliau nggak lulus pun kerja di Fisika, atau Mas Dono ini luar biasa, ini beliau advisernya Pertamina ya. Jadi proyek apapun harus lewat beliau ya. Jadi Anda kalau punya ide apapun, proposalnya Pak Dono, Anda bisa dapat proyek miliaran. Ya. Trust me. Tapi harus punya ya. Jadi sekarang trennya tidak lagi seperti zaman dulu, zaman saya, tapi betul-betul Anda punya sesuatu yang itu bisa Anda jual gitu ya, dan itu berguna ya untuk industri. Anda coba merenung, mengajak teman-teman yang bisa menyelesaikannya bersama-sama, bikin prototipe, Anda presentasi. Ya. Makanya kan banyak tokoh-tokoh itu yang mungkin nggak bagus ya kalau di promote di perguruan tinggi. Saya kuliah ya. Mungkin perusahaan yang luar biasa ya, dan mostly bidangnya ya bidang MIPA sebetulnya mereka itu. Jadi ini semata kami mohon fokus ya, jadi ya kadang-kadang distract sedikit nggak apa-apa, medsosan sedikit, tapi betul nanti lihat apa yang disampaikan oleh eksplorasi di laut, karena itu sesuatu yang menjadi masa depan kita. Indonesia itu kan belum selesai eksplorasi di lautnya, karena banyak sekali challenge, problem di situ, dan kesempatan Anda melihat problem yang terjadi apa saja. Kita akan ada kerjasama untuk memasang seismometer di sepanjang selat Lombok ya, sebelah timur Lombok ya. Ada ocean bottom seismometer ditambah streamer ya, dan elektromagnetik tapi di laut ya. Itu kita nggak kebayang. Kalau nanti bisa terus ke Pak Robi, I tell that we'll have experiments to measure along the close to Lombok Islands. With ocean bottom seismometer and streamers and also electromagnetics at the sea surface. So experience bagi Anda yang tertarik menggeluti itu, ini kesempatan Anda dekat-dekat ke Mr. Rawi. Time to approaching you, the students, they need experience. Once again, thank you very much for your time to share your experience today. Dan Pak Dono sekali lagi terima kasih dan selamat teman-teman, fokus ya. Kan sampai selesai. Panutan kita Mas V ya. Mas V itu tiru beliau itu kalau ada acara seperti ini pasti datang dia, dan paling fokus. Biasanya nanti suruh bertanya, beliau bertanya. Beliau PhD-nya di Taiwan ya. Speak Mandarin actually Mas. Okay, so enjoy the lecture ya. Selamat menikmati kuliah ya, ambil manfaat sebesar-besarnya. Kemudian harapannya Anda nanti bisa sukses di masa yang akan datang. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih kepada Dr. Ernat Wiwit Suryanto atas sambutannya.
Biasa ya Aisyah. Mungkin langsung saja materi tentang yang pertama, Onshore Seismic Acquisition and Seismic Data Processing. Dua ahli bidang Exploration Geophysics Advisor Pertamina Hulu Energi dan Regional Marketing and Operation Manager for Asia Pacific. Sri Sadono dan Mr. Qiao Yong, kami persilakan. The time is yours.
Okay. This is on, right? Okay. All right. So actually, later on, let's just give you the video that you understand what BGP is, and CNPC. Please, we can play. Is it possible the lights? No noise? No volume? Huh? But this one have no. What happened? No volume? This one, hello.
BGP is a governing member of Energi and a core member enterprise of EAGE and SEG. BGP's business spans across the world with operating footprints scattering over the countries and regions, while enjoying customer base in excess of 300 energy companies. Over the past eight consecutive years, BGP has been the leader in market share in the global geophysical industry. It is BGP's guiding principle to revolve the company's focus.
Jadi ada semua ya Pak Yong ini dari BGP kita ngasih kesempatan beliau untuk memperkenalkan company-nya seperti apa sih. Nah BGP ini adalah salah satu perusahaan core business-nya di seismic, salah satu yang paling besar di dunia. Dia di bawah CNPC. Apa itu CNPC? CNPC adalah Pertaminanya Cina. Jadi perusahaan nasional minyak dan gas di Cina yang paling besar itu CNPC ini yang punya BGP ini. Jadi kita lihat BGP apa yang bisa dilakukan di seluruh dunia. Jadi harapannya nanti ada link lah antara BGP, antara Pak Yong ini dengan UGM, dengan Pak Wiwit, kemudian juga nanti dengan adik-adik semua kalau ada peluang untuk bisa melihat ya. Harapannya seperti itu.
BGP has amassed an extensive MCMC library of 2D data, 3D data, magnetic and gravity data for over 20 countries, capturing some of the most significant offshore oil and gas exploration areas. We have established 30 seismic data processing and interpretation centers in the major oil and gas producing regions around the world to meet the broad needs of our clients. As a worldwide geophysical solution provider, BGP puts technological innovation as its top priority, continuously increasing investment in R&D to advance geoscience in the industry. BGP is not only committed to cultivating self-dependent innovation, but is also willing to collaborate with many other organizations for joint R&D. Up to now, BGP has carried out joint R&D with 46 renowned research institutions and energy companies. BGP has vigorously stressed that technological innovations are vital to its success, as demonstrated by the rollout of a series of core and proprietary technology packages that include the leading-edge Qiao East and KLC software systems, rugged and reliable seismic instruments, including the Quantum and eSeis land node, and the OSeis ocean bottom node. Also included are the customizable land source products to accommodate variations in terrain, environment, and imaging requirements, including the high-precision broadband vibrator EV56, the shear-wave vibrator BV310S, and other vibrator series, along with high-productivity, vibrosis technique, the digital C system, and UDAS VSP techniques, etc. The application of these cutting-edge products enables BGP to design more efficiently when executing the most complex seismic programs while lowering costs, improving data quality, and considerably increasing client satisfaction. BGP has developed WBH vibrosis techniques that have effectively improved the accuracy of seismic exploration, while the super large channel count plus bending high productivity acquisition plus the digital C system has greatly improved the efficiency and reduced the costs of acquisition. BGP's comprehensive OBN exploration strength is further enhanced by our world-leading OBN exploration technology with the development of the world's first shallow water DP vessel, the BGP Innovator, which has been independently developed and manufactured by BGP, providing exceptional stability in shallow waters to 5-meter water depth. BGP is constantly making new records for lower cost, higher efficiency, and better quality operations. The ultra-sensitive UDAS system has been independently researched and developed by BGP in the field of optical fiber intelligent reservoir geophysical services and has achieved industrial applications showing a broad range of market prospects. BGP can provide comprehensive non-seismic geophysical and geochemical exploration, such as gravity and magnetics, onshore, offshore, airborne, controlled source electromagnetic, CSEM, and magnetotelluric, MT, services in various terrains and environmental conditions. BGP is also rapidly developing renewable energy technologies that serve green energy development, such as geothermal exploration, CCS, and CCUS, amongst others. BGP regards zero injury, zero pollution, and zero accidents as its HSE targets, and adheres to the solemn commitment to not make profits at the cost of employees' life and health. BGP has achieved zero LTI operations for 4 consecutive years and will continue to strengthen the safety culture, making all efforts to improve and upgrade its HSSC management system to safeguard the people and the environment, enabling BGP to achieve and sustain a better than the peer performance in recordable incident rate per million man-hours. Additionally, BGP actively engages in a green seismic campaign to eliminate or minimize the impact of our operations on the environment. Even the vegetation, birds, marine mammals, and fish in the areas where we operate also can feel BGP's sense of environmental protection. BGP supports the philosophy of an open and inclusive culture, and we are committed to implementing social responsibility and promoting local development, actively integrating into the supply chain of foreign countries and developing together with local companies, which are essential in facilitating economic development of the countries in which BGP operates. We provide vocational training and job opportunities for local employees, creating an average of 50,000 jobs worldwide every year. And we prioritize local procurement to develop local economies and actively enhance communications with communities to contribute to local development. Over the years, BGP has won worldwide recognition, trust, respect, and has been awarded countless honors from the local governments and communities. One of BGP's core values is that the clients come first. We believe that creating value for our clients is our most important mission. We will endeavor to provide high-quality integrated services for hydrocarbon exploration and development, as well as helping energy companies develop their renewable energy portfolios while achieving the BGP's sustainable development and leading the contentious development of the geophysical industry. Beyond geophysical prospecting,
Okay, I think that's good. Yes, this one.于博士，你可以开始了。OK， OK。
Good morning, everyone. Very happy. Title of my talk is the applications of distributed optical sensing in oil and gas E&P. My name is Chen from BGP. Next time. Okay. Today I will give you a short presentation about our optical sensing. There's 4 parts. Quick introduction, then I have 2 parts about some special applications. One is for the Bawah seismic, the other one is for the reservoir stimulation and monitoring process. Then we'll follow the conclusion. Next. For the distributed acoustic sensing, it stands for DAS, is basically we're using this optical sensing technique. It's a fiber cable to recording seismic signal. It's recording both acoustic, seismic with the same cable. Also, it can be transferred the data to the same fiber. So here shows basically we have a fiber laid on the ground, floor or borehole. When the seismic energy comes to this part of the fiber where the stick is, the fiber gets stretched or compressed because of the elastic acoustic wave influence on the fiber. When you send the pulse of laser light through the fiber, and you get reflection back from every location along the fiber, we are recording the radio wave from the fiber. So when that part of the fiber got the length got changed, stretched or compressed, the light in the fiber will be affected, both the amplitude intensity, polarity, phase, etc. Today, most sensitive interrogation technique to interrogate the signal is phase interrogation, that's called SPI ADPR. And with that signal coming continuous recording, you will see along the fiber, only the part of fiber has been affected by the wave, seismic wave. We'll have anomaly, which shows on the blue, anomaly down the lower part of the slide. Rest of it is just the background noise. As the wave moving along the fiber, and you will see this anomaly moving along the fiber. It becomes a time series. You can record with the instrument, just like a normal seismic survey using geophone to record the seismic energy. Now we can use the fiber to record the energy. So just different recording principle and the instrument to record the same acoustic energy in the subsurface. Next. BGP has developed this its own interrogator, which we could use that. It stands for ultra sensitive distributed acoustic sensing seismogram. This one basically we are using a 1 gigahertz digitizer to recording the data. Once you record optical data and convert it to electrical signal through the converter, then we can record the data into the computer. This box has basically the string sensitivity. We will not measure velocity here, we measure the string, or string change. So this one we can record the sensitivity up to 3 picoepsilon around 20 hertz, equivalent to 0.1 nanometer displacement along the fiber. So 1 picoepsilon is 1 meter of fiber changing. As the cable is not longer than 5,000 meters. The sample rate we can pick by the computer basically 0.1 millisecond, 0.5, 1 millisecond, etc. The bandwidth with the system here, normally for seismic data recording, we use 1 hertz to 10,000 hertz. Normal geophones go 2.5 to 250 hertz, so it's a much broadband recording system. We have a laser source in this box. This source can handle up to 50 kilometer long fiber. We can recording data along that fiber as long as not more than 50 kilometers. So we can easily handle 10,000 meter deep borehole recording data without any problem. Next. Okay, for downhole applications, we basically put the cable inside the borehole, recording seismic data. There's 3 ways to deploy the cable. One is outside the casing. Basically, we put the cable in along with the casing, and we cement the cable behind the casing. That become permanent deployed sensor system. You can use the cable for seismic recording, VSP, borehole seismic. You can do cementation quality control. You can do fracking monitoring. You can do production monitoring. You can also do 4D survey. It's there forever. You can't get them out. So it's permanent deployed. The other one is we put the cable inside the casing if the bore has no tubing inside. So the cable can stuck in the borehole. Usually they will be attached to the casing and recording acoustic energy. We have different cable for this application. We have something called the self-adaptive that can stuck into the metal casing, basically have magnets, so you can get a good coupling, recording good data. Next thing is you can put also outside tubing by clamping them in the tubing when you deploy the tubing to the borehole. Then you have a semi-permanent deployed sensing array As long as tubing is in the borehole, you can always use it for recording data. You can record in seismic, you can record in the flow rate, you can record in temperature, and the noise inside the borehole. So these are different ways to recording data in the borehole using optical cable. Next. Okay, that's just a quick introduction. Then I talk about this acquisition. We're using this cable in the borehole joined with the seismic survey on the surface. Next. This is actually not updated yet, but we have done more than 20 projects in the last few years. When we're acquiring 3D seismic survey onshore, offshore for any clients, if they have borehole available, we put the cable in the borehole, we put the interrogator next to the borehole, we have some guy there sit there 24 hours a day recording the data continuously, where the surface seismic crew are recording the surface seismic data using dynamite, air gun source, or vibrate. So this workflow make you can recording both normal 3D seismic survey along with the 3D VSP data set. We call DAS VSP because you call it with the DAS system. So you basically have a very low cost. You can acquiring both surface seismic and the borehole seismic data together. Next. What we can do with the data recorded together with the surface seismic? One thing is we can do its own borehole seismic data processing, generate the VSP imaging, 2D, 3D, walk away. Or we can use the same data in the borehole, information from borehole, to enhance surface seismic data processing. So we call it borehole-driven seismic data processing. What we can do is we took the zero offset VSP, working VSP, and from seismic horizon, and we can derive the parameters of the tar value, Q value Q is an attenuation, and also anisotropy parameters from borehole seismic data. And then we can run our surface seismic with this parameter from borehole to do anisotropy migration, anisotropy plus Q migration to enhance our normal seismic data processing. Normally we can also calculate the Q value from the surface seismic, but that's not very accurate unless you measure in the core on the lab. So, but the VSP is direct measurement of attenuation from surface to TD, so we get a more accurate Q value than surface seismic data. And also, once we have a 3D VSP, like around the borehole recording the shot, the energy comes from different direction. We can calculate the anisotropy much better than the surface seismic because our recording sensor is in borehole. So you look at the deep formation anisotropy from VSP is more reliable than more accurate than surface seismic. So those parameters can be used to enhance our seismic processing and get a better quality of imaging and also keep the fidelity of the data. Next. Here's just general workflow, how we do this processing. Basically, we process borehole data first, derive those parameters, and then we apply it to the surface data to enhance the result. Next. And here is basically show you how this thing works. In the center, we have basically a borehole, has a cable and a geophone. Then we have a recording unit and also DAS. And the red dashed line are the source in the surface. When you do 3D survey, you can recording borehole data together in single well or multiple wells. And to deploy this cable, basically we have a truck and with a drum with the armed optic cable deployed to the bottom of borehole with the sinking bar. And this can help us to acquire high density, like we can achieve 0.1 meter or 1 meter spatial resolution of borehole data. And with one shot, we can record the data from the whole borehole from TD to surface. And also it's very efficient because you don't need to use your own source and very low cost. And also the fiber, if you buy today a 300 degrees C rated fiber, you can go to any borehole almost. Then you have no problem with the high temperature, high pressure issue with the sensor if you use fiber. With the geophone, you have a problem with the temperature issue. Okay, here is basically show some result. The left side is data record from a geophone array next to cable in the borehole. We see downgoing wave, we see upgoing reflection, we see also some shear wave. And the right side is the dash. This cable is basically outside casing. You see very good downgoing wave and also very, very clear convert S wave. So it means even as a single component fiber, you can still record the convert the shear wave. Next. As I mentioned before, we can use this borehole data to derive the Q value. Here shows you both Q value derived from borehole data. The top one is from geophone. You have multiple geophone in the borehole, and also lower one is a Q. So Q gets more dense Q value, but if you look at the trend, they are very similar. So basically, you can measure the Q using fiber, the same as you measure with the geophone. Next. I will show one. First, I'll show one case example. We have a 3D acquisition ongoing in the east of China. We have part of the acquisition areas in the shallow water. That's the lower right corner. So we have basically an onshore source and also have air gun source in the borehole. In this location, there's two boreholes being used, B-01, B-02, recording the borehole seismic data simultaneous with the 3D acquisition. Here, 倒回去一张。No, back, go back. Back, not forward. 往回走，往回倒，对，再倒一张。Okay. Here shows the B-01, B-02, well, how many sources were used for this VSP data processing. And if you see the table here, basically with geophone, we have only limited number of geophones. So we record at a 20-meter spacing. We covered from 520 to 2,100 meter depths. And we use a shot of about total 7 or 8,000 shot. For the B01, we're using cable, and we can record it from the surface to TD. And with the data output, we're using 2 meters spacing, 10 times denser than geophone. Same source, and we record about 8,000 shot. So that's the data we record from borehole with the two boreholes. One's geophone, one's fiber. Next. Now, there's 5 boreholes in this area. We only use 2 boreholes for the recording simultaneously. The other 3 wells we did basically survey before. So we took those 5 well data, we derived the Q value or model from each well and light up with the same horizon. So that's the Q value from the surface to TD in this region, 5 wells. This is our kind of homework, first step. Next. Here on this left side, on the top corner, there is a lot of dots in the square box. Those are the uphole survey. We did uphole survey in this area, onshore part, not offshore. So there's about more than 100 uphole survey data. We derived the Q from each uphole data survey to generate a shallow Q model, which is the left side model. Just reflect the shallow layer Q variation with very dense uphole survey measurement. And the right side is the 5 well VSP data derived the Q. We generated basically a 3D volume to match with the surface volume. Then we make a data fusion together, build a one model with very high resolution shallow Q, accurate, plus a little bit of coarse, but we still have 5 well controlled deep Q model. Make one model, then we can run the migration. Next. With the shallow Q, we have data derived from each uphole survey. Then we run a tomograph program called a software called QTomo. And that's when you basically fine-tune your model from just the interpolation to inversion. So you get a more accurate Q value. This only goes to about 200 meter deep. So it's not very deep, but it give you a very accurate Q measurement. Next. Okay, by combine two models together, we run the migration. Here is the result. Left side is normal conventional PSTM without the Q migration. And right side is with the Q migration. We add the Q parameters of Q volume into the migration flow. And you can see from bottom part, look at the spectrum. The Q PSTM give you basically 4 to 60 Hertz, where the normal PSTM only go from 5 to 42. So you have 80 Hertz high frequency enhancement. You can look at the image itself. You can see we see those circle area. We have much more fine high resolution imaging plus much sharp clean fault zones. So that's the one give you the vision of the data just by enhanced frequency. You get a high frequency data and you can do better interpretation. Next. Here's basically a time slice, about 2,000 millisecond coherence slice. We generate a coherence cube from each data set, and we take a slice about the around the reservoir. You can see on those three red circles on a conventional PSTM, you can see some fault zone, fracture zones, but they're kind of messed up, all mixed together. When you look at the right side, the same region, you can see those fault or fracture zones are much more sharp, much more focused. So this gives you much better data for interpretation if you're looking for tracking any of the structural features in the data set. Next. Okay, this is a typical 3D VSP processing workflow. When we do 3D VSP processing itself, we basically from full wave data processing, upgoing wave, downgoing wave, we do multiple images. Conventional VSP only take upgoing wave for the migration, but now we develop additional capabilities. We can migrate the multiple wave to enhance the imaging and also expanding the aperture of the imaging area much wider than just upgoing wave. Next. Here's another example from this offshore in the East China Sea. They are acquiring a 3D OBN survey, and we have two boreholes here. Basically, but we drop cable into both boreholes with optic cable. These two holes are just newly drilled, complete, has not been perforated, no production. So we drop the cable inside the casing, and here on the right side is basically the source map and the folder distribution with the OBN survey design. Next. Here are the actually 3D display of the borehole and also casing structure. The blue line is our optical cable. So basically just sit in the lower part of the casing because it deviates the borehole. In the B7 well is about 1.5 kilometer deviation from the wellhead. And the DG5S well basically is much vertical, but it's only still got 300 meter deviation. So that's our fiber in the borehole. Next. Here is the result of the imaging. Left side, we only take upgoing wave, upgoing reflection data imaging. And this gives us the imaging of this cone-shaped area because the limited imaging aperture, particularly from borehole data, as the recording cable is vertical in the borehole. But that's the issue is here, once you have given the borehole, you can have very limited imaging area toward the bottom of borehole if you only use upgoing wave. So we use the multiple, including downgoing wave, we expand the aperture much wider. This is the whole right side, the square is the downgoing multiple wave migration result. And the blue line is the same with upgoing wave data region. So we expand both sides much wider, so the client get more data for interpretation of the reservoir and trace the reservoir boundaries. Next. Since we have a much large data volume now, so we can generate a very nice data cube, and you can do time slice, attribute slice, and do the interpretation. They just show the data. Now you can do more than just the normal vertical outgoing wave imaging. Next. Here we show the 3 results. Left side is a vintage 3D OBC survey the client did many years ago. And you look at the arrow paths, they're not very good. The blue dashed line is basically if you do 3D VSP using data from borehole, you do outgoing wave imaging, you only get the blue line part of data. The middle part is the background is still the OBC data volume. No, OBC. And then we have insert the 3D VSP into the center, which is only outgoing wave imaging with the blue arrow coverage. We get an enhancement of those red arrow locations with the newly acquired 3D VSP dataset. The right side is basically we put the multiple image result, which is 2 yellow dashed line area, into the 3D OBC dataset. So we expanded the outgoing wave imaging much wider, so get more data volume from VSP imaging for interpretation. If you look at details where the VSP imaging, they have a lot of more fine structures you can use for interpretation than the old OBC dataset. Next. This is the other direction you look at, same data volume. So left side is still vintage 3D VSP, and the middle part is the new 3D OBN data imaging, because we acquired new OBN, so the OBN processing. And the right side is the 3D VSP multiple imaging. So you see those arrow plays has been much better compared to the OBC survey, and the client can use the data for interpretation and find a new reservoir. This is a mature field. They are looking for new horizon or reservoir to perforate producing. Next. Next example is also joint acquisition we did in Abu Dhabi. This is an interesting project. BGP is acquiring a high density OBN survey in this big blue red box. That's 1,640 square kilometers. And this is offshore. They have 2, not platform, but the production island artificially built. You see those in the lower right corner is set imaging of those production facilities. They are about 1 square kilometer to 1.5 square kilometer, quite large. They have facilities, many boreholes, production facility, control system, and the drilling rigs. They do multiple well into this different direction from this artificial built island. And we took 13 well in total on the blue dashed line box. We took 6 wells. They have a cable pre-installed outside tubing. So we just took our instrument there, 6 instruments, connect to the 6 borehole cable in the instrument room, recording data where they are acquiring OBN dataset. The source vessel bases 2 group source vessel moving east to west, west to east. So they call the zip 2, which is the blue salt line, and the zip 3 is the red salt line. They had overlapping, and 2 group of source vessels about 6 kilometers apart, moving parallelly east to west, west to east. So every location have actually 2 source vessels shooting at the same time. It's all what do you call this? Blended survey. So it's all crying together, and we're recording data with the cable continuously. day and the night. We did the first blue dashed line box area. It's called the Northern Island, and there's a gap. We wait for months, and we'll come back again. This time we put the 7 borehole cable together into the 6-7 box, record the zip-3 source, and totally we record about 5 million shots in this 2 dashed line box. And the raw data is about 800 terabytes. The principle here is every cable section has a maximum offset about 4 kilometers. If it's too far, we cannot hear anything, so we just take a part of the source for the processing. Okay, next slide. Here's a cartoon show you, because it's very large area, so when you put the source in the surface, 2 islands basically very close to each other. I think it's 6 kilometers apart. And the 13 wells are this the colored line. Okay, those are the horizontal wells, but the cable only installed till the turning point, not till end of the horizontal section. They don't have cable, so we only plot the cable part in this figure here in the 3D view, and then we can you can see the air gun source, multiple source vessels on the surface, and the right side basically is the recording room. We have multiple systems in the recording data set. Next. We can show you some results from this last survey in Abu Dhabi. And this is one of the line, inline 651. You see on the lower right corner, there is on this plot with the red line here, there is a hole in the middle. The reason is because the island is quite big, right? It's about 1 square kilometer, and the source vessel cannot connect close to the shoreline. It has to be 500 meters away from the shoreline. So there's a big gap in here. We don't have any source. That's why you see this map. You have basically a source gap in there. If you look at imaging there, there are some places you have blurred imaging. That's where the source is missing. So our client actually now is planning to add more source, smaller size gun, sailing close to the island, and also add vibrate on the island, see if we can do more data recording for the processing. This is the inline 651 for Northern Island, the top part. Next. Here is what the client gave to us, the same line, but it was old OBC survey imaging. They did acquire a new OBN, but that time was not being processing yet, so we only have this old imaging for comparison. So, but this is basically carbonate reservoir. Actually, is the largest, the largest offshore carbon reservoir, the 3rd largest offshore oil field in the world. They've been producing for 60 years in the carbonate. Next. This is the cross line 701. I try to cut the line basically avoid from the center of this island, because you have a big hole in the middle of data. So this just show you the imaging result. This is the multiple wave imaging of the VSP data. And one thing I need to tell you is the 6 well or 7 well they give to us, they're all production well and injection wells. The production injection ongoing 24 hours, they never stop during the acquisition. So we get a very, very strong production noise from data, and we have to do a lot of processing to remove it. And remember, one well is producing 12,000 barrels a day oil. Another well next to it is injecting 16,000 barrels seawater to keep the energy. So you can see it's a very, very high production field. And when we're acquiring 3D VSP data set using the cable outside the production tubing, we are not interfering with any of production. They're just ongoing as normal, and we're recording day and night. The source vessel is offshore on surface is shooting the data, and the sea floor they had a many OBN layout there. So this is just a joint acquisition with the minimum cost and not interfering with any production activities. Next. This is the same line, cross line, but this is imaging from the old Legacy OBC data set. just for comparison. Next. This is the lower Central Island, I think called, yeah. We have 7 boreholes. I didn't took the line across the center of the island. I still go up. This is inline 4901. And because we don't have any holes, so it's a very nice VSP imaging. Next. And this is what the client gives us, the old OBC dataset imaging. So very parallel structure. They had some special filter on the data, I believe. Next. And we took a cross line 1901. And you see on the top part of this line, we're just next cross another area without any source. So we have basically at 4709, 4759, and the left up corner we have some blurred imaging. That's reason because of we don't have a source in there. So in general, where you have source cover, you get a good imaging in terms of VSP imaging. Next. Again, this is basically the OBC survey from legacy dataset of the image result. Next. Okay, since we acquired both 3D OBC, OBN dataset, we also acquired the VSP dataset in the same area. So we have developed some new processing capabilities called the joint migration. We can do separate migration like this. Left side is OBN imaging. Middle part is VSP imaging. This is actually even multiple wave, but it's had a limited aperture. You see this area, we have very deep kind of structure on the OBN imaging, but not very clear. We see also part of it in the VSP imaging. But once we do joint migration, this deep structure going down on the left side of the imaging is much more clear than both of the other images. Also around the borehole area, we see more detailed of the formation because we have borehole data and plus OBN data. So this is combined imaging. It's a new development. Before we are using seismic horizon to constrain the VSP imaging. Now we are basically put the 2 data sets together, do some special processing, make the data are matching, then we run the migration together. So that's the joint migration, what we did. Next. You see this from the depth slice, about 2000 milliseconds. OBN survey, you can cover large area, but not fine imaging. Well, VSP covers small area, but has a lot more detailed imaging because of its high frequency capabilities. But if you do migration together, join together, you can see you definitely enhance the imaging accuracy and the resolution compared to just the OBN survey. So this definitely give you more processing, more interpretation data qualities. Next. Okay, next we'll talk about another application we are using optical fiber, not in the seismic, but for reservoir stimulation, fracture monitoring, etc. Next. This shows you in a borehole when you set the plug and run the perforation, run the fracking operation. We have a cable outside this casing, in this case, and they can record the noise in the borehole. So those on the middle part, you see those lines as each pinpoint when the drill bit is moving or set the plug or perforate, you can record those noise. And the right side actually is the dynamic is basically record acoustic energy on any of those events. So we can use this cable in the same borehole, not monitor microseismic, you cannot, it's too noisy, but we can monitor other activities. Make sure the engineering work in the downhole can be monitored through the acoustic signal, and basically you get some idea how this operation going on the subsurface. Next. Once you do the fracking operation, you have basically perforate the casing and you set the plug, then you inject the fluid and then you open the fracture and let the fracture growing, then you can producing unconventional reservoirs. So this is basically cartoon shows you this stimulation process and what we can record it in the data. We can record those on the right side of this blue color imaging, those tiny white parallel lines, those each line is one perforation. In this case, about every 3 meters there's a perforation, and we can now folks see this each perforation performance during the fracking operation. When you do microseismic monitoring, you basically look at the whole zone of the fracking, whole section, right? 100 meter, 50 meter, whatever. And you see the event growing, and you look at the envelope of the event and give you an idea how big rock has been fractured. That's the kind of very broad view of this operation. Well, here we don't do that. We cannot record the microseismic events to noise. But what we're recording is on each perforation, the acoustic energy with timing going with the pressure, it's a fluid into this fracture zone. Once you get in there, you can see very strong noise flew in, and you can generate the fluid noise. Those are in kilohertz. It's not seismic frequency, very high. That's why you need a dash. You can record a high frequency data set and look at this phenomena. And you can also look at where they have pressure drop, and you have you put in temporary blocking agent, and you can put a propellant. So every operation downhole can be monitored through both temperature changing and the acoustic noise changing. That's what we call the engineering monitoring of the fracking operation, because we're not monitoring the seismic event, we're monitoring the engineering process. Next. Okay, just different view of the data set, and we can generate basically a 3D view of those noise and temperature. And then we have a special software with this fluid model. We can basically generate a called the production or injection profile. In this case, on the right side plot, top blue red line is where each perforation and those noise in the data, which means the fracture has been opened, has been connected, and the fluid has been moved into the formation. Once you have a lot of noise, if there's no noise or vertical noise, it means this fracture has not been opened properly, it's not been growing, and only very shallow fracture. That's not good performance, or fracking is not very successful. And we generate this kind of lower corner of the right side is this bar plot. It shows you on this each section, you may have 10 perforation, and the higher the bar, different color means different section, means you have better performance of fracking operation. You have more fluid moving in. This fracking is very successful. We have very tiny bars, which means not being opened properly or even not being opened, and you may have to rework on those zones by additional engineering process, such like you put in temporary block agent, you block the one already opened, and you continue pumping, the pressure goes on those not opened zones, with additional pressure to open them again. So just a way to evaluating your fracking operation performance, and you can adjust your parameters on the spot with this information. So they come in the surface continuously, and you can display them at the same time for the engineer to look at them. Next. Here, basically, we show you we combine both DAS data on different stage and also DTS. Okay, in the cable, we have multiple fiber inside. We have multi-mode, we have single mode fiber. Multi-mode is for temperature measurement. You just hook into a DTS unit, basically distribute temperature sensing, interrogate, and then the single mode fiber you connect to DAS, then you're recording both data sets. And both can be used together to complement each other for your inversion processing to generate the flow rate and the variance, and we'll give a rating of the performance of each zone, and then we'll give adjustment parameters, so the client can use this information to adjust their stimulation parameters on the spot. Next. Here we have some kind of cartoon shows you on the left side. Basically, we're using this single well, same well cable monitoring the fracking operation in terms of fracture opening, closing, fluid come in and propping come in, etc. On the right side, we can use the same fiber monitoring next well microseismic event. We can't measure the same well because it's too noisy, but the cable's there in the outside the casing permanently. With the next well fracking, you see those dots are popping out. That's why we're using the cable in the center well monitoring the microseismic event on the next well. So the cable can be used monitoring itself on the injection processing, fracking, and also can monitor nearby borehole microseismic event. So it's kind of two, one stone for two birds kind of scenario. Okay, next. Next thing is very popular these days called the frac heat. Basically, the fracture from frac well growing towards the parallel neighborhood well. But if it's the pressure too high, it could damage the next well for causing the casing deformation. So you need to monitor that. So and in this case, we are using a different equipment called the low frequency dash. Basically, you can measure very, very low frequency strain change. How low is it? It's 0.1 millihertz. Basically, you can measure up to 10,000 second slow deformation. With this system here, and we can monitor this frac heat. In this case, this is a simulation. Basically, show you have center well is doing treatment. The next well is the red color lines have fiber cable in there. So when you're pumping into the fracture with the high pressure fluid, the pressure goes towards, slowly moving towards this monitoring well. And you want to make sure you don't damage the casing. If there's a fracture going through and hit next well, the pressure comes too high, it could damage the next well. So this is now become quite a popular practice to monitor neighborhood well, make sure they don't get the casing damage during the fracking operation. Next. Here are the real data set actually. We can monitoring from the frac well to near cable well. It's just like the simulation data. You go open, closing, hit the casing, and open again. So this is basically a very good live view of the pressure growth inside the borehole and whether the borehole got damaged or not. Or you can do this kind of monitoring with this low frequency dash system recording data continuously. Next. Here is basically once you finish fracking, you finish the fluid extraction, then start production, and you have fiber cable in the borehole, and you can record in acoustic noise and temperature from those production zones. And you can basically come with, after the immersion processing, you can generate the production profile, which here shows on the right side. And basically you have a total volume at the surface. And then you can actually derive each zone of perforation zone or each fracking section, the performance or contribution to the production. Which zone is high, which one's low, which one producing gas, which one from water, which one from oil. It can all be derived from the data set. Then you can do some additional processing, such as you can block the zone with high water production. You can enhance the zone which has not been produced properly. So this is the way basically the production engineer needs the information to make sure this very long horizontal section can produce more hydrocarbon than just water or low production wells. So this is something really help them to diagnostic any problem in downhole along the many fracking stages and check the performance and using some special engineering processing to enhance the production and increase the recovery rate. Next. Okay, here basically shows something else. We have deployed the cable outside the casing, and we inject the cement from bottom hole and to cement borehole, basically well completion. Normally, after the finish, the cement dried up, they drop the two downhole to check the cementation quality of the casing. But in here, we don't need to do that. We just use the cable in the outside the casing, recording temperature continuously. Then when the cement is cooling up, and the temperatures go up, right? Usually you know that, getting heat. So temperature changing along the borehole tells you how much cement is in there, what any problem. Some places have no cement. So this temperature data can help you to basically evaluate your casing, your cementation operation, if successful or not successful. So just additional tool help you do this work without running another logging trip to just measure the cement quality. Next. Here's the real data show you the temperature moving with the timing, and you get this interpretation. You basically know where they have problem with the cement in the subsurface. Next. Okay, here's basically an example of injection production. You injection profile. You generate this profile from the data here, and you know which one has been connected, which one is not connected, and you know your performance of the fracking, but just by looking at the injection performance. So if you want injection water into right zone, you make sure the water is in there, not in other locations. And you don't want the water goes like a straight line, go to the next well. You basically have a breakthrough. You want the water pushing uniformly, push the oil into the production well, not water. So this one give you a good idea about how you are injection well performance. Do you actually increase the pressure energy of the subsurface, enhance the oil production, or you just basically sending water through to the production well, end up producing more water? So there's something here for you to evaluate your injection operation. Next. Another issue here is during the drilling, sometimes you drill into a zone which is a big cave, you lost all the drilling fluid. In China, we have cases, some of the drilling fluid are very expensive. They're like $1 million RMB, I don't know, $150,000 a one, 10,000 cubic meter. So very expensive. If you drill into big hole that just suddenly lost, you cannot afford to pump in more because you don't know how much they're going to take. So you need to quickly identify the zone where they have leakage. Before they're using normal sensors, they get up to 10-meter arrow. With cable, we deploy a cable, we measure temperature, we can spot onto this leakage zone, which plus or minus 1 meter accuracy. So give kind of very quick timing to identify the leakage zone, and then quickly reaction to block this zone and continue drilling, not abandon the borehole. So this is another application we're using, basically temperature measurement of the fiber cable, quickly identify the leakage location in the borehole during the drilling operation. Next. Okay, I have given you two quickly application in the seismic part and also reservoir stimulation production part of the 5 applications. Now is some quick conclusions. Next. Okay, the DTS is that semi-acquired seismic data has many advantages, including low cost, high density, and a full borehole coverage, and also can stand for very high temperature. We have borehole now in China is 270 degrees. There's no any tool, logging tool can go that temperature. So fiber maybe is one of the options. BGP can provide the customized DAS-based survey to satisfy different requirements of the clients. And we can, the DAS-based itself can provide a high efficiency, high density data set, reduce operation cost and timing significantly, and a much better result with higher resolution than surface seismic in objective area. Horizontal well with armed optical cable outside the casing can monitor fracture operation, and the comprehensive interpretation can be obtained by DAS, DTS, low friction DAS, and the microseismic event. BGP as a service company, we can provide the DAS, DTS, dynamic monitoring system and service during well completion, and production, including wellbore integrity, cement quality, and the production of injection profiles. So all those are enable BGP to move in from just exploration into production part of the service work. I think that's all I have. Next, maybe more, no more. Okay, thank you very much for your attention. Do you have any questions?
Okay, I have two questions. For the first questions, what are the limitations of the DAS system?
Okay, for borehole seismic, usually we're using 3-component geophysics downhole. Okay, now of course there's commercially available 3-component optical geophysics system in the world now. You can buy it basically. So if you just use DAS, it's one cable. They're not 3-component, they're a single component. So that's the limitation. If you use just cable compared to geophysics array, you don't record the 3D data, you don't record the 3C data, you record the 1C data. So that's the limitation. But if you adjust the cost and also the density, and also normally we do VSP imaging, we only use the vertical component. We don't do, few people do 3-component data imaging. Because surface data most today, onshore is still vertical geophysics. There are some 3-component one. Offshore, of course, it's OBM, but they're really for converted wave. But you can see our cable can record the converted wave as long as the polarization direction is parallel to fiber. So that's the limitation one. Basically, the DAS, a lower cost sensor, can only record a single component, while the 3-component geophysics array can record 3-component data downhole. We actually developed a 3C DAS system. It's on testing now. It's 3C DAS. It's not 3C individual optical geophones. But now it's very big. Diameter is about 10 centimeters. So it's very difficult to put in borehole and make them very long. So that's but we did record 3-component data. It's very special structure with multiple fibers, not one fiber. The other issue is on the surface. If you lay a straight fiber on the surface, you cannot record the vertical reflect wave because the incident angle with the fiber has a function is cosine theta square. Theta is in incident angle. So when the energy comes parallel to fiber, angle equal to 0, the coupling is best. You get a 1. When you have energy coming 90 degrees to the fiber, cosine theta square 90 degrees 0. You have no response. So vertical, no, the horizontal fiber is not very good for near offset reflection measurement. You don't get the data at all, or very bad data. But of course, far offset is okay because far is not 90 degree. So many people using this straight fiber on the surface, recording surface wave. Because surface wave is a polarized circularly and it's parallel to the fiber. You can record a very nice surface wave, but not very good with near offset reflection data. So now people doing called a helix wind. Helix wind is just basically have an elastic a bar, 2 or 3 centimeter diameter. Then you put the cable on the roll around with the angle, 30 degree, 45, 60 degree, like that, and you put on the ground. Because the fiber is not parallel to the ground, it's got angle. So you can record the vertical reflection data with that helix wind fiber. This is a kind of improvement if you really want recording reflection seismic data. We are now building a 5-kilometer long helix wind fiber cable shipped to Houston. ExxonMobil is going to put on a subsurface, measuring the 2D reflection data for the CCS monitoring. So if you just look at a single fiber, the two limitation. One is, okay, horizontal fiber cannot recording vertical incident angle energy, and also borehole single fiber cannot record the 3 components. So that's 2 limitation, as I can see today. But we're trying to work on as additional development to overcome those problems, like here's one fiber for parallel on the surface, and also 3C dash for maybe borehole application in the future.
Okay, thank you for your elaborative answer. My second question is related to the processing of the DOS VSP. I've never worked with VSP data before, but I was wondering, suppose you have or you run a DOS VSP through slanted well, or you have a tilted formation, which means the sensors itself is not always parallel to the formation. And I was wondering, how are you going to signals coming from the slanted formations? Does that affect the quality of your signals overall? And if you do, how do you correct it? Thank you.
Okay. Yes. In the vertical borehole, you do worker VSP or 3D VSP. You know your instant angle. You can do a correction during the processing, right? But if it's deviated well, slanted well, what we do normally is we took the borehole trajectory into the processing flow and project all the cable into vertical direction. You need to correct that first because your VSP data measurement is basically from vertical borehole, supposedly. You're not, your data is not from vertical, so you have to convert it to true depth and also make them vertical. If it's a 30-degree angle, you have to do a correction rotation of the data basically to make them correct to 30 from 30 degree to 0 degree. Then you get a uniform the VSP data, just like a 3-component geophone. In the deviated well, you still have to rotate the data, right? Because the geophone is also line in along the well trajectory, not always vertical, unless you have gyro. Nowadays, nobody using gyro anymore. They just all direction geophone. You do the correction using the well trajectory. So you do need to have well trajectory data for this kind of correction. Once you correct it, and your recording is optical data, but we have a software basically convert optic data into the acoustic wave data. So you basically have the same data set, but one thing you need to remember is if I give you a dash data set without tell you anything else, it usually is only measure the stream rate. The unit is meters, not meter per second. So if you want to compare with the seismic, you need to convert it into a seismic data like velocity. You do a derivative to divide it by time t to get it to velocity data, or you can even convert it to accelerometer data. So you need to do conversion if you do comparison of the data set. We have done this quite many times. Both same spot recording that and geophone, if you put together next to each other, they are different. But if you do a derivative and they get a match, basically. So there is a way to process in this data set. This is why that's has been now more than almost 10 years being used for borehole seismic. So the special software handle that data processing now with the special modules. Because they're not the same as geophone or accelerometer, so you have to do some pre-processing to be able to go. After you finish the pre-processing, you can do using your normal seismic software to process the VSP data set.
Okay, thank you.
Any more questions? Thank you to Mr. Yugang for your presentation on distributed fiber optic sensing technology and its applications. After this, we will have a 15 minutes coffee break. Setelah ini kita akan 15 menit untuk coffee break, lalu kita akan melanjutkan acara kita dengan materi yang selanjutnya.
Okay, thank you very much.
Oke.
Thank you,
Kepada
Mr.
seluruh hadirin, dipersilakan untuk menikmati hidangan.
于博士，那好了，那这边待会儿那个10分钟的间歇休息时间，10 minutes。
Kepada seluruh hadirin, dipersilakan untuk menikmati hidangan yang telah disediakan di ruang sidang ini. Terima kasih.
Pak Yong yang akan ngasih presentasi pengenalan mengenai offshore seismic. Jadi offshore seismic adalah salah satu core business dari BGP. Kami di Indonesia, beberapa oil company juga sekarang lagi aktif untuk melakukan eksplorasi di laut, baik di shallow maupun di deep water. Jadi kita bisa lihat nanti bagaimana pekerjaan seismic offshore dari sisi operasi, dari sisi teknologi akan ditampilkan di sini. Nanti mungkin ada beberapa tambahan yang bisa kami jelaskan setelah presentasi ini. Oke, your time, Pak Qiao.
Okay, I'm from BGP Offshore Division, so mainly the acquisition part. Next, let's go next. Next. So actually, in China, we have 3 oil companies. In China, we have 3 oil companies, which is one Sinopec. We are CNPC. BGP is under CNPC, and also CNOOC. Probably here now you heard about CNOOC and CNPC. Sinopec just signed blocks over here, and next year Sinopec also will come into Indonesia. We are here. We are CNPC, and PetroChina is our company, but we all under CNPC. Here for BGP actually used to be only geophysical division under CNPC. We are founded in 1951, and since 1972, we officially call BGP. We have our division have our own name that actually is a Bureau of Geophysical Prospector. Then until 2002, then we separate from the government, but still under CNPC, we become enterprise. So in 2002, just BGP. There's no the other meaning. BGP means what? No meaning. But here is bureau, still government. But on 2002, we be becoming enterprise. We do business for CNPC, also for the other oil companies. And next. Here, look at based on client's requirement under BGP, we have seismic acquisition and data processing interpretation, reservoir analysis, and geophysical research and development. And also we develop our own software. We have a geophysical software and borehole, and also non-seismic means gravity and magnetometer, this kind of thing. And geothermal. Equipment manufacturing, some of equipment we made by ourselves. We design and manufacture by ourselves. There's another business, multi-client business. Here, BGP headquarters in Zhuozhou. That's our headquarters building. And BGP Offshore is under. And we have BGP International, BGP blah, blah. There's several divisions down there. Next. This is our building BGP Offshore. Our headquarters is at Tianjin. This is our Tianjin headquarters. Look at BGP Offshore, mostly offshore means TZ, transit zone here. Land, intertidal area, shallow water, and deep water. This terrain, we normally work over there. It's okay. It's okay. Our business covered ocean bottom node, OBN, and ocean bottom cable, OBC, is a little bit old technology, but recently not a lot of clients require this kind of technology anymore. Instead, OBN and towed streamer seismic. Streamer here actually uses the name of streamer, actually is kind of a cable. This cable is the cable is about 5 centimeter. The diameter is 5 centimeter in the water, and there's hydrophone, everything built inside. That's the receiver. We call it streamer. And multi-client business. Okay. These are our streamer vessels. We have a flagship, it's a BGP, we call it BGP Prospector, 12 streamers, and each cable is about 8,000 meters, and the separation is about 100 meters, but maximum is 112 meters. So the cable is from Sussex, Sentinel RD. And BGP Explorer, a little bit smaller, at a time can tow 4 streamers, 4 by, and 4,500 meters a streamer. And this Gilava, also small one, 4 streamer. BGP Challenger is a 2D vessel, 2D vessel, and also for the moment in Abu Dhabi we use as a source vessel, airgun source boat. Dongfang Canton number 1 is the 2D vessel. Now for the moment we put her still Abu Dhabi as a airgun source boat. This boat have been in Indonesia several years ago, 10 years ago actually. Did some 2D work for Repsol Indonesia, for Repsol, Stat Oil, and Pertamina EP, blah, blah, everything. This boat have been in Indonesia, used to be. And those kind of boat, you look at actually source vessels, the shallow water, airgun boat, shallow water. This kind of, is deep for deep water. Here is for shallow water. Node handling boat. We sometimes, some area, we try to find a local boat. We convert it, convert back deck. And DFKD2 is BGP design, BGP build. And some of this cable boat, we also BGP design, BGP build, and also this for the OBN. It's an automated deep water OBN handling boat, transfer OBN. Next. Shallow water source vessel. BGP Innovator just launched this year. BGP Innovator. This boat is a shallow water, shallow water OBN deployment, handling, and airgun source boat. This hybrid boat. And this kind of boat, you looks like more like sea truck, sea horse in Indonesia, but we also build this kind of boat typically for shallow water operation. This is OBN nodes. This is the equipment receiver we have now. You see, it's Fairfield Z100, and also this one is max size Mars 2, and this one is from Geospace. We call it OBX 750, and this one is BGP node. Actually, we team up together with Sussex. We manufacture this GPR 300, this nodes in China. The amount, actually, we just counted to the end of 2022. In the last 2 years, at the end of the year to Q4 2022, we already have 110,000 nodes. But in the last 2 years, we built another 40,000. So for the moment, up to today, we have 150,000 nodes already. For this one, for intertidal transit zone area, this kind of a craft, you said the vessel, the drilling, and even this kind of a vibrator we use for the dry sand, dry area, TZ. Even some in the water also okay, but not too deep. This is for for transit zone area. This is a drilling for explosive. We also have mud gun. Okay, next. Okay, here is the clients. There's the clients we worked for, including CNPC, here, Petronas Indonesia, here, Eni Indonesia, BP Indonesia, Pertamina, EP, PHI, and Repsol, sorry. Yeah, PHI, WJ, that's PHI. And EP, even at a time before we have EP, now we don't know EP anymore, but just Pertamina. Next. This is the area in the last 15 years BGP Offshore have worked for. Those are all around this global, all around the world. Say we served for 80 clients already. Okay, next. Okay. Business management. Okay, next. Okay, and I think because you just still in the school, later on when you finish school, you try to work for the oil company or geophysics company like us. Here in Indonesia, we have Aernosa, right? That's your under Pertamina. Aernosa is, they provide the same services as we are BGP. Now students actually, after you graduate, maybe you choose your career, maybe you have to go to the field. Go to the field after a few years, you probably will go up and go into the management. Management, how to manage a project. So that is the thing you have to understand systematically to manage each project, systematically to manage the whole company is the key for two oil companies now. Every oil companies, they look at you, you just cannot, that's the oil, go there, just work. Without assessment, without risk assessment, everything, they will not let you do it. So in this case, probably that's why I say BGP now, we have very, very big improvement in the last 15 years based on the requirement from the clients. Pertamina is our clients, also BP is our clients. So in this case, so I want to say QHSE, human 5 main elements. Human resources, occupational health and safety, environmental management. We do some work, we try to get something, but we don't make a mess of the environment. And after that, risk management, that's the last one. Next. Quality management. We get data, we acquire data, make sure the quality can meet client's requirement. That's quality management. No, stop. So ISO, that's the quality. That's a basic, they say, we meet IOGP report, blah, blah, 5 main elements, blah, blah, thing. This is all part of a BGP management systems. So, go down. Probably for this one, I go very quick. So when you finish study, if you decided to go to the work, go to the field, probably you will be at this level. Task risk, location risk, because cannot be just go there, becoming a partnership project manager. You must have your experiences, and you will be at here. And after a few years, you're becoming the partnership, then probably you will be at here, project risk. Now one day maybe we become president of Aernosa, you will be here, cooperate risk. That's the pyramid. Try to use the risk management to manage the company, human, and projects. There's a bunch of documents, you know, the policy or whatever, a lot. So this kind of thing, a lot. Now go next. Yeah, next. IOGP, okay. Seven phase approach, how you manage it. There's go down. Here, phase 1 all the way phase 7. Some of the paperwork, but this paperwork can tell you each phase what kind of thing you need to improve. Now go through, go down. Okay, so the phases, okay, go down. That's quick. And in the last 5 years, we just use FLAG. We call it FLAG. This is kind of software to build big data for BGP. We import old history, everything, and for the moment, each team, all the events we register into FLAG. Use FLAG, you can get a statistics of how your performance, everything, every week, every month, every year. We call actually big data. We also call big data. Big data. Try to from the old history and until now the new problem when what we should do next. So this FLAG system for a company now we feel is very, very good. This kind of software becoming a tool. Go down. QHS update contractor management. Okay, quick. OVID, this kind of audit, everything. Okay. Next. Yes, yeah, next. Yeah, I'm not going to tell you this how this kind of works, but I just tell you we use this system now very successfully manage a lot of huge projects in Abu Dhabi. Go down. Okay. So that's some safety factors. Not only human. Also, it's a fatal, it's an LTI, also equipment damage, also including environmental damage. Okay, I go down. Okay, this kind of software can give you the data, from the data, each data, and sometimes you say you talk with your leader, your up level, say, I want to do this one, I want to improve this one. Why? You must show something to them. Okay, during the work, we have this kind of problem. We must change. So, go down, quick. Okay, the policy, because we're a global geophysical service company, different language. So, but I don't have here in Indonesia, but PGBGP also have. We have a local Indonesia is a policy. Okay, the training for our employee each year, after from slow. Now we are here, continue growing. Go down. Okay, go down. OBN. So now why now OBN, ocean bottom nodes technology becoming. There's a trend becoming. We think it's a revolution, even because we also with the clients we're also thinking OBN technology is a revolution. Basically, so OBN is 4 azimuths. Realize 4 azimuths: high fold, high resolution, long offset, and higher signal noise ratio. And in the last 30 or 40 years, we use total streamer. And look at the data, we say low quality imaging because we compare with OBN. Actually, streamer data is okay, but OBN data is better. You say the limitation for the total streamer, we have a limited offset. The streamer length, maximum now we can tell is 10 to 12,000 meters. But for the OBN, depends. 16,000 meters or 20,000 meters, as long as the energy source is strong enough, you can, as per your need, you can do this one. And because here, compromised velocities, and here high resolution 4-wave inversion velocities, and partial illumination, the target down there, because is not 4 azimuths. For illumination for the target is partial, we call it narrow. But for OBN, we can achieve 4 illumination, the target. And look at the quality, it's okay. Little bit blur, little bit clear. Go down. Okay, next. Up. Sorry? Very slow. Batteries. Oh, sorry. Battery.
Oke, untuk isi sebelum ini reconnect lagi ya. Jadi mungkin Pak Qiao ini memperkenalkan perusahaannya ini. Walaupun secara umum memang perusahaan-perusahaan seismik itu seperti itu gitu ya. Jadi apa yang bisa mereka kerjakan untuk mendukung pekerjaan-pekerjaan eksplorasi di seluruh dunia begitu. Memang GPGP ini perusahaan yang kuat karena di belakangnya negara ya, kayak Pertamina, di belakangnya pemerintah Indonesia gitu. Jadi itu kenapa banyak perusahaan-perusahaan Amerika, Eropa itu kolaps karena BGP. Kalau mereka kan perusahaan-perusahaan itu kan tidak disupport oleh pemerintahnya ya secara finansial, tapi kalau BGP ini secara finansial fully support by the government of China. Nanti saya lanjutkan lagi.
Yeah, for the OBN acquisition, it's a no limitation of channel count. Say you can use a lot of receivers compared with the streamer, and very flexible design, and based on the target illumination requirement, and we can make a four azimuth, high fold, and simultaneous shooting, and to improve efficiency. And it looks at the complex area, have the platforms, and you deploy knows how to deal with this kind of environment. And also here, deep blending technology. Let's go. Go down, yeah. Okay, that's a typical equipment we're using for zero to shallow water. It's a high tide water line. From source, we have deep, shallow, very shallow water. Source vessel use air gun. Air gun is compressed air release. This air gun. And node handling boat also have the shallow water and deep water. Special equipment for the positioning system. The system we use unmanned. Unmanned is kind of a ping boat. Because that ping boat because node you deploy into the water, you need to know the position of each receiver. So we use a unmanned pinging boat, and nodes with GPR 300 and the other nodes. For the moment, basically now BGP only use GPR now, because we manufacture this one. Go next. Here for the source vessel and both, probably from this picture, intertidal area, all the shallow water, and down, and to the deep water. Deep water normally look at the boat to capture the draft. If the draft is 5 meters, we call it deep water. From 8 meters, deeper and deep water. Good. Next. Also node handling, and this kind of node handling boat, node is receiver, how we deploy our receiver into the water. From 0.5 meter to 1 meter, 2 meter, 4 meter, 7 meter. Here, typically this we just launched a new boat, BGP Innovator, and this boat is for shallow water operation, have a huge air gun source, and also automated node deployment equipment. Next. Next. Here, shallow water Raja boat, and this one small one. Probably you also can see this kind of boat in Indonesia. Okay, go down. This is unmanned. This is unmanned positioning boat, controlled by radio link. This very efficient. It's very efficient because also now required more and more by clients. If the work area inside there have the platforms. This kind of small boat, very small. It's a little risky if there's some corruption or mistake, corruption. This one very little damage. If you use bigger boat, If you touch the platform, that's a big issue. So in this case, for this one, it's required more and more by the clients. Go down. Navigational boat. So you have a limited. So that's why if we use this one, close approach. Normally we say 200 meters, right? But this kind of thing, if you use this one, maybe client will let you go just 50 meters, more close. GPR 300 designed by BGP and Sasser. The battery life, we can put in the water, it can last about 60 days, continue recording. Now this kind of node we have 120,000 GPR 300 now. Okay. Done. Next. Okay, that's the OBN geometry design. Most of the time, if there's a project coming, we will work with the client very closely. For example, you look at this terrain. Here from land, TZ, water, and here, this is the bay. This is the bay. How we can, if we want to acquire data over here, how is do the geometry design? We will work closely with the client to make say target around service type, operational conditions, and equipment availabilities. Yes, OBN. This OBN design. Simultaneous shooting. Actually, we improved the efficiency. We improve efficiency. There are 2 air gun source boat shooting on both sides. In the middle, there's a node patch. High efficiency. We try to achieve high efficiency. Okay, next. Yeah, next. Okay. Now deblending. So it looks like some without deblending technology. At the time, we think this is the interference, but now after deblending, clear. You can get what you want. Okay, go. Next. And this one also have more and more requirements from the client. Actually, streamable plus OBN acquisition. We call it hybrid streamer. Streamer plus node acquisition. Down there is sparse node. Up there, your streamable shows through. That is the case. We have done for the client. Next. Here is only streamer data. You plus OBN 4-way inversion, and if you combine together with a hybrid, these 3 pictures probably you can see the difference. Okay, quick. Okay, next. This is our automated node handling system on the back deck, and BGP design. Also, we manufacture this kind of thing. Nodes on the transferring belt convoy. Okay, good. And also for containerized node handling, charging, downloading, and if we just bring equipment to the country, find a suitable boat, just put container on it, and convertible, becoming a node handling boat, containerized modules. Okay, go there. Dolphin navigation system is a BGP software. We develop this software typically for TZ and OBN operation. This year, the Dolphin is updated to Dolphin 2, upgraded to Dolphin 2. That's a BGP integrated navigation system. Going down. Now, OCA is for streamer. Gator is for OBN, but sometimes streamer boat, you use Oka, Spectra, whatever, with Gator together, two boats. You need something, combine them together. Now BGP only one dolphin, integrate everything. BGP, dolphin 1 now, dolphin 2. Next. And also dolphin integrate this one, the vessel tracking system. During operation, probably in the area, you have more than 10 boats working over there. With our GIS node system, you can monitor each boat traveling. Make sure the safety. This is part of dolphin real-time network. Okay, good. That's our acoustic system, BPS positioning system. Normally this one go down there, combined together with the receiver. Use this transponder, we will know where is what's the position of the node. That's the pinning picture, and try to pin the position of this node. Next. Okay, so normally acoustics positioning is on the vessel. There's a transducer talking with OBN, and once you deploy OBN into the water, there's a position we go around, have pinning, and try to understand where is the exact position. Because in the water, not like on the land. On the land, you can have a GPS, you know all the time where is it. But in the water, you have to use a pinning acoustic system to position this kind of node. Even sometimes combined with the first break positioning. Okay, because we BGP develop node business, so we also use the clone size. Clone size also BGP software. Under clone size, we have node QC. There are 3 modules developed by BGP. Node QC, first break, AGQC. This one actually was at the time we developed these 3 modules typically for BP Indonesia project. Okay, next. Now we're getting more and more OBN projects. So we have more and more different requirements from the client. So we have a set of QC software already developed as per requirement from clients. Linear move out, blah blah, node, azimuth, QC, blah blah, several, three components, rotation. Okay, go down. Okay, quick, go down. Down. Yeah. This is one case. The one area project as a probably high efficiency, 1 minute line change time, and because typically for this one we use our USB. His module system, we build this module and put container inside. That means how efficient we can convert a node handling boat, how we can minimize the mobilization period. Next. Okay, case 2, probably this one you say, for this project, we involve 60 vessels. Actually, from this one is Abu Dhabi project. The clients are ADNOC. At Abu Dhabi, we have 4 crew. We have 4 crew over there. 4 crew. We total have 60 vessels. Go. Okay. Conclusions. BGP integrated OBN acquisition solution includes large node counts, different type of the source vessel, node vessel, based on the terrain, the water depth. Simultaneous shooting for simultaneous shooting to improve the efficiency, daily efficiency. Actually, there's another English word, identical simultaneous shooting, ISS technology. This the first we use at the Middle East for BP land, and the first offshore is here, BP Indonesia, simultaneous shooting. And also in the last few years, we improve our efficiency to deploy node and recovery. And also we try to improve our navigation system, Dolphin, and the control system to make sure the safety efficiency in complex and congested or field area. And node position, so we use our BPS. We make sure each node have one positioning transponder. Okay, good. Okay, I think pretty much everything. The next still some equipment. Go. I can go very fast. Yeah, go quickly. Go. Yeah, before broadbanding processing, after broadband processing the data, and we undershooting. There's a platform in the middle, streamer boat, airgun boat, side by side undershooting, and also our our technology with a triple source with a wide tow streamer, streamer acquisition as a streamer seismic. Go down there. And for the airgun, we also have the design for broadband airgun source. Okay, go down. Great. Okay, like this picture, I believe there's 4 more slides. Go down there. Shallow water to deep water, down. Multi-vessel high efficiency blended shooting. Okay, that's pretty much, go down. Yeah, LBNK, that's a navigation system. BPS positioning acoustics, force brake, peak and solution. Okay, go down. Finish? Huh? A little delay. Okay, all right. Okay. Yeah, before just like I say, deep blending. Now we control the technology of deep blending, so this is no more noise anymore. You can pick up whatever you need. There's the continuous recording and ISS shooting. This technology. Go. Yeah, there's a node handling. You look at back deck. Amazing, so many nodes. Normally, middle-size node handling board, we can hold about 4,000 to 5,000 nodes on a vessel. Yeah, go down. Okay, next. Very slow. Okay, okay. All right, so this picture shows something Qiao knows QC software. Okay, that's our software. Column size QC. OBN data processing. Broadband processing, multiple removals, converted wave processing. Okay. Go down. Finish? Sorry? Okay. We test all size 3,000, all set 300. We tested in the last year and this year. And next generation of the deep water OBN and shallow water OBN, this 100% BGP design. There's no cooperation. Actually, GPR 300 is BGP and SOSAR. We team up together, design everything. To manufacture in China is with SOSAR. But all size is 100% BGP product. We tested in the last 2 years. We are promoting now. So some of these nodes already put in use in China. Good. Good. All size, the performance, everything tested. Okay, good. All size 300 nodes, yes. The specification. GPR 300 nodes. Okay, go down. Innovator at the boat, BGP design. Innovator boat. Okay. Go down. Yeah, shallow water. Shallow water HYWT 200 series. Okay, go down. Yeah, Roger, shallow water. The depth is over 1.3 meters. Okay, go down. You look at this one. It's a vibrator for shallow water area. Shallow water area. Even if stuck in the water, you can up and down, can get himself out by himself. It's a vibrator. BGP design. Okay, go down. Next. Software, Dolphin. Integrate, I just mentioned it's a Dolphin 1, Dolphin 2 navigation system. Go down. Yeah, make it quick because this kind of thing just know we have this software. See if slow. Almost finished, huh? Okay. Column size, yeah, column size. Okay, this size, column size. Column size also BGP software from project start, design, operation, QC, and this column size. Okay, next. Finish, not finish. No. All finished. Now, case study, share Brunei project, this kind of thing, I think I just pass it. Case study, pass it. Just let you know equipment. So in this case, say, I just want, because when you finish school, choose your career. You say, when I see a lot of BGP design, BGP manufacturer, BGP user, I hope someday when you go to Pertamina or whatever, SKK, whatever, and also the other oil companies, you can try to think something innovation, do something innovation. For BGP at the very beginning, we buy. We buy, we use, and we maintenance, repair. After that, based on client's requirement, how we can do development, improve, and become our own product. You have your own product, nobody can choke your neck. This time you look at Windows. Windows stopped service for Russian, right? So all Russian computers stopped. So in this case, does not mean just the one case, does not mean they will choose, but better have your own technology. Better have your own technology and you sell your technology and your service. Also just like Huawei. Okay, this is what I want to share my experience to you. And for the offshore equipment, just pretty much this. So you have any questions? So I can any questions? Yeah. Oh, okay. Start from.
Sir, excuse me. However, I need to ask about the containerized node handling system.
Okay.
containerized node handling system in layman term is separating a system into several modules before attaching it together in a marine vessel to ensure that it can handle said system. However, there is a concern about it being compatible with various type of node itself. It's how BGP capable of ensure that there's connection within its module to ensure its efficiency, sir. I will repeat my question first. BGP have used a containerized nodes handling system to ensure that its system can be included in every and each marine vessel. However, there is a concern that well, each marine vessel.
Each marine vessel.
Yes.
For the operation, how to say that we have node handling boat, air gun source boat, supply boat, chase vessels. The containerized node handling system only put on node handling vessel. Find a bigger hole and put on it. Just put containerized. And for, you say how to connect them together, right?
Yes.
Actually, for the node itself is one unit receiver. Have battery, have a memory, everything inside. Just pick up everything. You don't need anything. That one node, when you deploy in the water, you pick it up. Put on the containerized charging, downloading. Simple. That's each one. There's some picture you look at. This one's slow, right? This one's slow. There's one picture. Let me see. They're containerized. Actually, here, you see? It's not this picture. This one. Did you see this one? You want to know how node inside of container, right? How to connect them together?
No, how its container is connected to one another.
Container with container have nothing to do.
Oh.
Container inside node because it's very, very independent. One node uses a cable, charging, download data, and transfer back to your instrument room. Each node goes through this kind of, you see the cable goes through to there. Container connect to there, container connect. There's a center over there. That's the instrument.
I see, sir. Thank you. For
You have to know first how node works. Node deploy into the water. Okay, just try to record. As I have the seismic signal coming, record it on the memory. You have the battery. Can last 60 days. When you pick up, put over here, charging, download. Quite simple. Compare with the streamer boat, this one is very simple.
yes, sir.
That answer your question?
Yes.
Okay, sorry. Okay, all right.
Yes. Thank you for your information, sir.
Okay, all right.
Okay, thank you for your time. At last, you say make innovation, right?
Innovation.
Yeah. In terms of technology, how far has BGP developed? Like using machine learning or AI to managing data.
Actually, for innovation, so how BGP becoming kind of a leader, right? The technology leader. Actually, at the very beginning, we don't. We just buy. Buy after that, and during maintenance, our guy follow and look at the inside, what is inside, and try to team up together with some pioneer, pioneer provider. We team up together. That's why BGP also GPR 300 team up with CSER.
Yep.
CSER. And after that, actually, then we try also improve based on our industry, in China industry level. Sometimes you have an idea, does not mean the other people can make it for you. So you have to base your country's industry level. We have an idea, find our manufacturer, we make it, then we can make it. But idea, design, we always follow international standards, also the latest requirements. If say how we design this, actually, I don't think design this kind of thing we need AI, big data. This kind of thing just based on, because we are oil and gas industry, geophysical, we are not very, very popular. We are not aware. We just serve the oil and gas industry. Seismic, in the last 50 years, becoming very, very efficient survey method for the oil and gas industry, land and offshore. You also can think there's some of the other methods, because probably you studied gravity, magnetic, right? EM, electronic magnetic for the land. CSC, control source offshore EM. It's also aero gravity magnetic. This kind of survey is only assistant way for seismic. So in the last few years, seismic is this method for this industry. In the last for the until now still use seismic. I don't think we use it. We just use big data to try to improve our management, the managing levels. Make sure people working with us, together with us, were safe. First, the human, people is safe. The second, environmental is okay. And also your equipment damage, this kind of thing.
Okay. But how you managing the big data for the seismic data?
Seismic data, all this improve technology, like
Yeah.
computer, everything.
Yeah, like that.
Yeah, later, Chen just imported a very, very good processing into Indonesia. One actually used to be used, you know, a computer, now you use computer very good, right? i5, i7, at that time when I worked, the computer is 286. Intel 286, 386. Probably you never heard about it kind of computer. But until based on the technology, the hardware technology, CPUs, everything, and even input output of the hardware, the SDD, and also computer memories, we can handle big data. At time for BP project in Indonesia, that OBN data, one day we handle about 6 terabytes. One day. 6 GB. Only one day.
Okay.
And if you later on when you have a chance to visit China, for example, in the future, you look at the facility, you have a whole floor. They have
You invite them.
the whole floor of the road processing, whole floor of all the cluster cabinets. Okay.
Thank you.
All right.
Oke, saya mau menambahkan ya. Jadi saya nggak yakin ini rumit apa presentasinya ini mengenai barang-barang kayak itu ya. Jadi saya akan sesuaikan aja. Maksudnya ada semua masih sekolah ya. Di geofisika, ada yang di fisika, ada yang di matematika dan sebagainya. Saya dulu fisika, bukan geofisika, tapi kerja saya di geofisika. Karena kalau nyari duit ternyata enak di geofisika gitu. Jadi yang diterangkan ini memang apa yang menjadi bisnis BGP kan seperti itu. Mereka mampu segalanya karena disupport uang yang luar biasa besar. Cina itu nggak terlawan gitu. Memang luar biasa gitu. Beberapa perusahaan besar selam bersih, selam bersih punya Western Jico, kemudian CGG, collapse semua gara-gara BGP, ya kan? Dimakan sama BGP sampai saat ini gitu. Karena muncul yang lain lagi itu juga masih terancam juga oleh BGP karena memang mereka luar biasa disupport oleh company-nya. Jadi kalau kita bicara geofisika atau fisika atau yang lain, itu identik dengan seismik kan seperti itu ya. Kalau kita bekerja di perusahaan minyak, itu ada 3 stage dalam hubungannya dengan seismik. Satu adalah akuisisi, bagaimana mendapat data akuisisi itu. Setelah didapat, ada namanya processing, diproses data itu. Data diproses sebaik-baiknya agar bisa apa? Bisa diinterpretasikan. Jadi ada acquisition, processing, and the last one is interpretation. Nah, nanti terserah adik-adik suka yang mana. Ini akuisisi nih. Itu, akuisisi itu seperti ini. Nanti processing dijelaskan Pak Chen. Nah, bagaimana memproses data itu. Kan seperti itu pekerjaannya, tujuannya bagaimana kita bisa mengkolek semua data, terutama data geofisika, data subsurface, untuk kita gunakan untuk studi-studi berikutnya, sehingga tujuannya kita bisa mendapatkan informasi yang valid, yang akurat tentang subsurface, di mana kita bisa mengambil minyak, mengambil gas dari situ gitu. Jadi kita nggak perlu rumit-rumit lah. Nah, kenapa akuisisinya seperti ini? Kalau kita tertarik nanti bolehlah kita kasih sesi lagi ya, karena waktunya kan memang sangat mendesak. Kalau kita bicara barang-barang seperti ini mungkin perlu 2 hari lah. Jadi nanti bisa kita teruskan. Jadi kalau kita bicara seismik tadi diterangkan oleh Pak Yong, di situ ada darat, di situ ada namanya transisi. Ini berdasar area pekerjaannya ya. Kemudian ada shallow water, dia di laut tapi yang dangkal. Kemudian ada deep water, laut yang dalam. Ya tentu saja alat-alat yang digunakan di darat, di transisi, di shallow water, di deep water itu beda-beda gitu. Nah, tujuannya apa? Kita dapat data sebaik-baiknya. Data sebaik-baiknya itu apa sih kalau kita bicara seismik? Kualitasnya baik. Kualitas baik itu apa? Bahwa bahasa geofisika itu ada namanya, atau bahasa fisika ada signal to noise ratio. Itu harus bagus. Signalnya itu harus prominent, harus dominan terhadap noise-nya, kan seperti itu kan? Dan sebagainya. Kemudian kita punya target subsurface. Di sana perlu frekuensi berapa sih kita harus dapat? Nah, itu harus kita kejar gitu. Itu bisa semua dari prinsip-prinsip fisika digunakan untuk menghasilkan data yang atau target yang kita harapkan seperti itu. Jadi nanti adik-adik semua kalau udah lulus tentukan, saya mau di akuisisi ini, tertarik ini. Kalau cuma mau di meja, di processing lah kerjanya di meja. Ya kan, pakai software processing, utak-atik di workstation, interpretasi GNG itu. Tapi kalau mau jalan-jalan ke hutan, ke tengah laut, jadi koboi di akuisisi gitu. Jadi terserah tertarik yang mana seperti itu. Biasanya langkah pertama itu akan menentukan masa depan kita. Gitu. Kita sebagai manusia itu biasanya bertahan pada status quo, di mana kita udah merasa nyaman, kita nggak mau berpindah kan. Itu udah sifat dasar itu. Jadi tentukan dari awal. BGP adalah salah satu kontraktor seismik kelas dunia. Kalau di Indonesia ada namanya El-Nusa, tadi disebutkan oleh Pak Yong kan. Banyak lagi yang lain gitu. Jadi harapannya ke depan adik-adik semua bisa menentukan di mana kami adik-adik itu bisa melangkah berikutnya seperti itu. Jadi jelaskan alat-alat itu tipe spesifik untuk masing-masing area gitu. Yang pasti tujuan kita apa, mau mendapatkan data subsurface itu, bawah permukaan itu seperti apa, kepentingannya untuk apa dan sebagainya. Alat yang kita gunakan, jenis seismik yang kita lakukan seperti apa akan menentukan hasilnya. Seismik itu ada 2 macam, kalau kita di eksplorasi ada 2D seismik, ada 3D seismik, ya kan? Diajarin kan di kampus, di kuliah. 2D itu apa sih? 2D itu cuma 1 garis saja. Di situ ada source, di situ ada receiver dalam 1 garis. Jadi datanya cuma 1 strip aja. Kemudian 3D apa? Nah, di posisi receiver line atau lintasan receiver dengan lintasan source-nya masing-masing berbeda. Kan seperti itu. Hasilnya apa? Dia menghasilkan data seismik dalam bentuk volume. Yang satu dalam bentuk garis. Seperti itu. Nah bedanya apa? Tentu saja beda secara cost, secara ongkos. 3D jauh lebih mahal, berlipat-lipat dibanding 2D. Karena secara resources jauh lebih banyak secara waktu penyelesaian atau waktu kerjaan jauh lebih lama seperti itu. Jadi kemudian kalau kita bicara seismik itu ada, kalau bicara data seismik ya, data seismik itu bisa dicari, bisa kita dapat yang paling bagus itu kalau ada prinsip-prinsip namanya satu. Satu adalah, ini agak maju sedikit ya, adalah wide azimuth. Tahu nggak azimuth itu apa? Diajarin nggak di kuliah? Ya kan? Nah, semakin banyak azimuth semakin bagus, tapi semakin mahal. Ya kan? Jadi kalau kita bicara 2D, satu garis itu narrow azimuth. Kalau kita bicara pernah melihat namanya Ross diagram, nah itu cuma satu garis saja. Kemudian berkembang menjadi katakanlah race azimuth atau multi azimuth, yang bagus wide azimuth, ada namanya full azimuth. Semakin kaya azimuth itu semakin bagus karena memberikan iluminasi yang jauh lebih bagus dibanding less azimuth, kan seperti itu. Jadi nanti itu ya dipelajari. Azimuth itu salah satu yang menentukan kualitas data seismik. Yang kedua apa? Yang kedua adalah broadband seismik. Itu. Apa broadband itu? Jadi jangkauan data dari low end paling rendah, frekuensi paling rendah sampai tinggi itu lebar. Kalau kita biasa ngelihat data seismik di frekuensi rendahnya kan paling sekitar 8 Hz kan. Nah itu kalau bisa jauh lagi lebih turun. Karena apa? Penetrasi itu lebih dalam, jauh lebih dalam. Kita ke dalam kita perlu low end frekuensi atau frekuensi rendah. Itu disupport oleh apa? Satu, tentunya disupport oleh source yang kita pakai. Source-nya mampu, receiver-nya nggak mampu, nggak jalan. Receiver harus mampu. Jadi low end frekuensi receiver. Itu tadi Pak Coyong bilang. Di situ ada namanya nodal. Dia itu untuk broadband seismik. Jadi secara kualitas lebih bagus. Tapi harus wajib azimuth. Caranya ya dibikin 3D. Jangan cuma 2D gitu. Yang ketiga adalah high density seismic. Semakin banyak source, semakin banyak receiver yang kita pakai, itu semakin bagus. Karena data yang di-collect semakin banyak. Risikonya lagi-lagi cost akan tinggi, kan seperti itu. Jadi 3 itu kita pegang, data seismik kita bagus. Walaupun tentu saja desain sangat menentukan. Jadi sebelum kita melakukan seismik, kita melakukan desain dulu. Kalau kita punya data lama, kita punya data sumur, itu bisa jadi bekal, masukan nanti untuk membuat desain. Sehingga target subsurface, objektif, itu bisa kita dapat sesuai apa yang kita inginkan. Desain salah, buyar semuanya. Ya kan? Jadi salah satu rohnya seismik akuisisi adalah, karena kita bicara seismik akuisisi adalah desain. Mungkin adik-adik pernah dengar namanya MESA, pernah dengar belum? Kemudian Jolan, kemudian Omni dari Selam Bersih, yang baru ada namanya Norsar dari Norwegia itu. Nah itu semua dibuat untuk mendesain sebuah seismik akuisisi yang robust, yang bagus gitu. Belajar itu. Jadi karena kalau kita masuk nanti di oil company itu apa itu seringkali pertanyaannya macam-macam gitu. Tidak perlu tahu dalam, tapi paling enggak pernah mendengar, pernah ya baca gitu, itu penting itu. Kita bisa bercerita gitu. Jadi tolong itu nanti dielaborasi lebih jauh ya. Seperti itu. Nah, desain ini menentukan. Kalau di laut, kita bicara desain di laut ya. Kalau kita bicara tadi ada namanya streamer. Streamer itu kabel panjang gitu. Di dalamnya berisi hidrofon. Teknologi lama. Sekarang di dalam hidrofon dimasukin geofon. Sehingga muncul namanya dual sensor. Muncul namanya multi komponen. Itu tujuannya apa? Tujuannya untuk mengimprove data seismik. Ini bicara teknologi nih. Itu sangat penting. Kemudian kita bicara OBN, Ocean Bottom Nodes. Itu juga teknologi baru. Dari sebelumnya namanya OBC, Ocean Bottom Cable. Dulu setiap receiver itu terhubung oleh kabel. Kemudian dari itu semua terhubung oleh namanya kita bisa bilang kalau di darat orang bilangnya labu. Di situ ada recording system di dalam kapal itu terhubung semua. Kalau dulu teknologi lama namanya ocean bottom cable, sekarang ocean bottom node. Dia autonomous. Jadi dia ditaruh semua di tempatnya masing-masing, di posisinya masing-masing sesuai dengan desain itu. Begitu syuting, dia otomatis akan merekam data gitu. Itu begitu luar biasa kan. Tapi tentu saja pekerjaan seperti itu pekerjaan yang butuh effort yang lebih. Itu kenapa kalau kita bicara seismik bahwa menggunakan ocean bottom node itu adalah sampai saat ini adalah pekerjaan seismik akuisisi yang paling mahal. Ocean bottom node itu bisa sampai 1000 meter kedalaman laut, bisa sampai 3000 meter. Jenisnya macam-macam dibagi berdasar kedalaman. Karena di dalam kan pressure besar ya. Jadi mereka didesain untuk yang misalkan kedalaman sampai 100 meter aja pakai ini. Sampai 700 meter pakai ini, sampai 1000, sampai 3000, masing-masing punya gitu. Tetapi itu tadi ada irisan antara streamer dengan OBN. Tentu saja karena streamer, kalau kita pakai survei dengan satu kapal saja, dia kan narrow azimuth. Sementara nodal kan wide azimuth, azimuth yang lebih banyak kan. Dan tentu saja secara kualitas akan jauh berbeda. Tadi tunjukkan dari Pak Coyong, ini data pakai streamer, ini pakai OBN. Kan jauh berbeda tuh. Ya berbeda, harganya juga berbeda gitu loh. Tapi kalau kita berhasil ternyata dari data itu di dalamnya kita bisa dapat minyak ya angka akuisisi dan sebagainya itu kan terlalu kecil gitu loh. Ya kan? Jadi adik-adik pokoknya yang sekarang sangat diutamakan itu bagaimana punya view ke depan gitu dulu aja lah. Jangan bicara yang terlalu jelimet dulu, kapal-kapal itu tadi. Itu pendukung semua gitu. Tapi pada dasarnya bahwa kita sebagai geoscientist harus bisa menghadirkan data yang kita perlukan sesuai harapan kita. Jangan melenceng dari apa yang kita harapkan, kan seperti itu. Jadi kalau kita bicara pekerjaan di situ ada namanya geophysics, di situ paling dominan kan semua. Tapi nanti kita akan berkolaborasi dengan kalau di laut yang berhubungan dengan yang dibilang apa tadi itu dolphin dan sebagainya itu berhubungan dengan positioning, berhubungan dengan navigasi ya istilahnya kalau di laut. Itu orang-orang geomatik. Orang-orang yang dulu namanya geodesi ya. Ya, sekarang namanya geomatik kan. Karena mereka yang diajari hal seperti itu. Di kapal ada geophysics, ada namanya navigasi, ada namanya observer yang mengamati kualitas data, dan sebagainya. Jadi banyak jenis pekerjaan yang ada di situ ya nanti adik-adik semua bisa mana yang tertarik sih gitu. Jadi enggak ada salahnya belajar geofisika juga belajar geomatik. Enggak apa-apa gitu. Boleh enggak ikut kuliah di geodesi? Oh ada kuliahnya, ya itu penting itu, seperti itu. Jadi bagaimana melakukan pengukuran topografi kalau di land itu pakai total station apa itu kan? Itu penting, punya pengetahuan tentang itu. Kombinasikan dengan pengetahuan geofisika. Jadi harapannya kita itu lengkap gitu loh, itu lengkap. Saya dulu diajari dosennya Pak Wiwit itu teori relativitas kuantum. Waduh, udah pelajarannya susah, mau dipakai apa juga nggak tahu saya. Ya saya mending switch ke geofisika aja lah yang lebih membumi lah gitu. Jadi apa namanya harapannya bisa menghasilkan itu, bisa berguna untuk keluarga gitu. Jadi adik-adik semua itu ya gambaran bahwa geofisika itu sangat erat kaitannya dengan pekerjaan-pekerjaan eksplorasi di perusahaan minyak. Pekerjaan-pekerjaan itu dilakukan oleh para kontraktor karena memang mereka perlu apa namanya investasi yang besar dan itu perusahaan minyak tidak perlu invest alat-alat untuk melakukan hal seperti itu. Mereka tinggal menyuruh kontraktor bayar, kalian lakukan, aku punya parameter seperti ini, ngikuti aku, jangan terlalu banyak modifikasi dan sebagainya. Semakin banyak modifikasi, banyak toleransi, data kita semakin tidak jelas. Ya, jadi itu adik-adik semua. Kalau mau tahu lebih dalam secara apa ya, secara science nanti bolehlah next time atau mungkin boleh telepon saya anytime. Saya kasih tahu, saya jelaskan nggak apa-apa. Nah ini gambaran aja dulu, karena masih mahasiswa saya dulu juga nggak tahu apa-apa. Kalau kita kasih beban yang berat, nanti malah pindah jurusan kan susah nih. Jadi harapannya jangan takut lah, jangan takut gitu. Geoscientist jangan takut. Jadi masih banyak lah opportunity. Nanti saya akan juga bilang ke katakanlah BGP di sini yang ada BGP. Kalau bisa nanti ya ada link lah dengan BGP. Siapa tahu ada yang lulusan dari sini bisa punya peluang, kesempatan ya kan. Belajar nggak usah lama-lama. Misalkan ke BGP nggak perlu bertahun-tahun, setahun cukup. Nah, pindah ke yang lebih bagus lagi, setahun lagi cukup, pindah lagi. Saya dulu begitu gitu. Jadi kadang-kadang kesempatan kalau kita lepas, dia nggak akan datang lagi. Itu. Jadi ingat-ingat, kalau ada kesempatan bagus, tangkap dia gitu. Nggak apa-apa. Karena kesempatan itu nggak akan datang lagi. Atau mungkin waktunya lama nanti akan datang lagi. Sementara kita udah bertambah umur kan seperti itu. Nggak apa-apa bila itu akhirnya kita nyampe ke puncak gitu. Jadi harapannya lulusan dari Geofisika itu bisa itu tadi sampai ke puncak itu ada yang lebih idealis ke arah teknikal bagus juga, tapi ada yang cepat juga bisa mencapai level manajemen gitu. Jadi saya pikir bekal yang diberikan di sini di MIPA ini sangat lengkap ya. Di situ ada matematika, di situ ada kimia, ada fisika, dan fisika bumi sendiri. Jadi banyak sekali alumni yang sudah istilahnya sudah kemana-mana ya. Jadi harapannya menjadi contoh kita semua bahwa ada nyala terang di depan yang kalau kita serius, kita tidak menyia-nyiakan waktu kita, pasti akan kita capai. Nanti kalau ada pertanyaan, silakan. Terima kasih.
Okay, so today I'm really happy. Actually, this is not my first time go to Jogja, but I go to the university the first time. It's a long time I haven't been to the school, so I'm really happy to see so many young faces. Yeah, it's my pleasure to share some of my experience about the seismic. Because we know we already have so many discussions, so maybe I try to make my presentation short and interesting, yeah, as much as possible. Maybe not success. But before we start, we want to introduce about the industry, about the seismic. Yeah, because Sadono already explained briefly, and I try to explain in my words. Yeah. Actually, for the oil and gas industry, we normally start from the G&G study. The G&G study, we found the target where we want to have the oil and the gas. And with gas, maybe this part hell. So what we can do? So we have to plan the non-seismic survey to find the potential area. And after that one, we will do the seismic design for the target, what we want to do. Yeah, we want to guide the target depths and what the structure, which method we use, 2D or 3D, yeah, and what the details for the acquisition. After acquisition done, so we can do the processing. This is my major. Yeah? I do the processing to the image because the data we got from the raw shot is shot together. We can get only limited information from that. From processing, we can generate section. Like we take photos and we can get a beautiful view, yeah, like that. After we do the processing, do the image, and we have the study, we call the interpretation. We can find the potential location, and after that one, plan the well, the drill. And the drill, we got the oil, gas or not, we repeat again to the first stage, go to the G&G study. Yeah, so this is the industry for the how we work, and we are part of the industry. And for BGP, actually, we come, oh, it's not, oh, be late, yeah. Oh, sorry, maybe this not later, doesn't matter. Actually, next slide shows the BGP come to Indonesia. Actually, BGP come to Indonesia from 2002. We have been here more than 20 years. And both processing and acquisition do a lot of work. And the next slide shows some experience of the acquisition. But it doesn't matter, they not show up, we can jump. And I want to show the next one. Not so good, yeah. Okay. Next one, we want to show this one, the experience, the past already passed. So next one, the photo I want to show, we have some photos about how we work during the land acquisition. Because for the marine biology, explained a lot, yeah, how the streamer works, how the OBN, and why we use OBN. And now we use, this photo shows how the land operation works. Traditionally, we use in this tool page, we use this cable system to do the acquisition. And from the photo, you can see it's very heavy. For the people carries units, 2 people can maybe several channels only. And for the new acquisition, for one shot, maybe we active channel maybe more than 5,000. Sometimes the new acquisition maybe 10,000. So it's almost impossible for the man people to carry one by one like this one. So that's why we propose you to use the nodal system. So you see the 2 people maybe carry 2 or 3 channels, but here 1 people can maybe carry 10 channels. And with the nodal system, we can do the acquisition faster and easier, and the quality also very good. And nodal system also can be applied in the border area, yeah, because we have the external connected with the geophones. Okay. Oh, maybe it's really take time. Yeah. 要不然设置一下，把这个直接投在上面去，可以设置吗？Okay, that's so slow. So this several the nodes. This is the different kind of nodes, and this totally different from the photo. We can see totally different with the cable system. So each one has its advantage, but this is the future of the acquisition. Okay, this is the field operation, and after acquisition finish, so we can download from charging and download it. Similar with the OBN, but it's huge. But for the onshore node, it's smaller. So each one we can see they can download the data, and at the same time they finish charging, so they can go to the field to do the acquisition again. So So this some experience we apply in Indonesia. It doesn't matter. And during the nodes also we do some tests about how it works and in what condition it can be reliable, what cannot. So I think later the picture will come, will show up. Yeah. So this one we field operation, how we plant the nodes in the field and bury it, and it works and without the notice. And it's recording 24 hours, maybe one month. And after recording finish, we just pick up. And this one test, this is the test we use, the long tail or short tail, which one can receive the signal better. And how about the water condition? We place the node into the water, it works or not. We also had a test of this kind of things. And also in the next picture, we show if they're in the water areas, sometimes the signal not good, so we have to plant the node in the high parts, maybe along the tree or something like that. But the external geophones can be placed in the water. So this one just be the recorder, and the signal come from the external strings. Yeah. Maybe not still not come. 没有，这个电脑已经过去了，那边没有翻过来。Okay, this is almost the brief introduction about our node system, how we do the acquisition. And later I will show you something else about the seismic. This one we use place the geophone in the water, and the receiver can be outside. So this one can recording. But this one we will show about the low frequency vibrator, because conventionally we know in this area mostly we use the dynamite as the source to generate the view, and we record it. But also we have another technology with the vibrator, this controlled source. And the vibrator conventionally is a narrow bandwidth. But in some particular case, the high frequency was absorbed by the Earth, so they cannot image the subsurface very well. So we propose to use the low frequency vibrator. So this frequency, this use the swap signal, different with our dynamite. It's this one after we had to one more step to convert to so it's similar with the dynamite. So it's some different technology lah. Yeah, and this one later maybe one more section come out, because BGP we developed the low frequency vibrator. It start from the 1.5 hertz. The swap start from. And later we can have a section to compare the vintage and conventional one and the new one. Conventional normally is from maybe 8 hertz and above. So, but it's from 1.5, so low frequency can help a lot to image the deep target, and especially in the very broken area. So this is the example. This is the vintage conventional vibrator. So this is the narrow bandwidth. You can see this even start from 12 hertz the section. And this one, the new acquisition, we start 1.5 hertz. So the low frequency, we can see they contribute a lot for the broken area. So if we have the some part is really challenging, I think this one would option. Okay, so this is the brief introduction about the onshore acquisition, and I want to show something about the processing. It's
Pak Chen yang bilang tadi mungkin barang-barang filmnya bahwa yang sekarang itu adalah broadband. Jadi secara frekuensi broader, lebih lebar dibanding yang tadi itu yang disebut sama mereka itu ketinggian range, jadi frekuensinya itu dari 10 sampai 100 tinggi. Sementara yang kuning yang dibilang smart itu dari 5.
here I want to show, okay, oh, not stable. So later we will show something about the processing. Yeah, because acquisition everybody already have the idea. And processing is the after acquisition. And the processing, I think with the everybody sitting here is maybe more related with the processing because we use the computer a lot and a lot of interesting story behind that. And this we brief introduce about my department. Actually, I come from PGP GRI. GRI is the Geophysical Research Institute. Before they also owned by the government, and now we have more than 2,000 employees. And actually, one will say this part. This normally what we do, working like this one. We use the computers. We have 2 monitors. Yeah. And next slides we show the equipment we use for processing. What we use for processing, we use the computers. We call this the PC cluster. So it's many PC connect to each other, and we call it each server. It's on the rack. So this one the processing is under the server like this one. Actually, in our headquarters, we have 1 building to place the servers, and it's a huge cost and a huge consumer about the energies. Actually, in Jakarta, we also have 1, but also bigger, smaller one. Yeah. And the next slide, we show our experience in Indonesia. So actually, BGP processing in Indonesia around 20 years. We run around the 90 per day around Indonesia. So almost every island already touched. And the next slide, we show our capability of processing. So processing, we know the BGP offshore do the acquisition in the shallow water and deep water, and also TZ, yeah? And the BGP onshore do all the onshore acquisition. But the onshore is the very general, say like that. Actually, it is including the different terrain also. So the processing and the acquisition that we can see in the mountain area, we can do the acquisition perfectly, and also the processing is good. So this is very deep. They targeted more than 6 kilometer depths. Yeah, it's mountain area. And also in this TZ area, also we can processing. So it's a full terrain, we can do the acquisition and processing. It's our capability. And this is in the west of China. This we call it clouds. Some clouds we can image also. And this is what we can do. And next slide will show up about the offshore data processing. So the offshore is normally the offshore data quality looks better. It's higher High-Emission ratio, but they have a lot of multiples. And the most short period multiple is about the ghost. We call it the ghost because the short and the silver located in the water, but the sea surface and the air is a good reflector. So between that, we are generating the very short period multiples. In this case, we will separate with the other long period, so we call it ghost. So deghosting, after deghosting, the ghost was removed, and then we can see the frequency band. It's become flattened, and this is the effect of the ghost. So without the ghost, the section is higher resolution. With the ghost, it's the narrow bandwidth, and it's not good. Yeah. Okay, this is about our multiple removal. So the shallow water and deep water with a different technology. Yeah. And this is the multiple for the subtractions. So this actually this is a short gather. Yeah. This is the before node station. This after the field acquisition, we got the shot like this one, and they have many multiples. The other nodes removed, but still have the multiples. We can see this highly related with the water depths, and it's almost time the 2 times about the water depths. So here the multiple, we can build the multiple model and subtract with a different method. So after the good subtraction, the short gather become cleaner. So without the multiples, we can image the data is easier. Yeah. And after that one, we proposed about the velocity model building. For the model building, sometimes we have well data. We'll have use the well to constrain, and also the structure to constrain to build a velocity model. But now the most popular way is about FWI, we call it. we call this FWI to build the velocity model. Because all the seismic we do for the shooting the seismic onshore and offshore and do the processing. In my mind, the very key answer we want to get is the velocity model in the subsurface, what it looks like. And now we have the FWI, and this can help us to generate a velocity model is much more reliable. And this we can tell is part of the machine learning or the AI because it's programmed by the human, but it's totally data-driven. Yeah. Except that theory about the FWI, also I showed some examples about our depth migration for the diffraction imaging. Actually, this in the Central Asia, this project, and we can see this the conventional processing. We can see some abnormal here. But when we do the diffraction imaging, we separate the view field into the reflection and the diffraction, and process separately. But after migration, so we can merge them together, so we can image the geo body is much more clear, and this already proved by the well. We drilled the well and found it similar thing. Yeah, so this is very interesting, and seismic really can do a lot of. And next one, we want to show some case study. Yeah, now the network become faster. Yeah, this is the streamer. This streamer data. Yeah, so it's multi-streamer and there's a triple source, and it's a continuous recording also. So the next slide we show the shot gather. Yeah, this is the raw shot gather. So this the total streamer recording the data, but this is a shot we want. But before that, in the part they already have this shot of energy from the last shot. And when this recording, the next shot is coming also. So this one also come. Yeah. So actually in this shot together, it's more than one shot. How to separate? If we use this one to stack, we got the section like this one. Here it's full of noise, and the shadow part also noisy. And for the deep blending, we use the spare inversion. Yeah, can perfectly separate the shot together. So this is the one after the separation. And we can see this very strong energy. Another shot is already disappeared. So with this one, we can see the cost for the acquisition is higher efficiency. And with the stack section also showed a very good result. Yeah. So this is the technology applied in many projects. In the streamer, in the onshore acquisition, especially if we use the vibrator, maybe one day can reach 10,000 shots. And the OBN is very widely used. So it's commonly applied in the industry. It's also about the developable and zero phasing. And later this slide shows the IPC. IPC also is the estimate primary based on the spare inversion. Actually, this with the same theory with the deep blending. But here is very useful for the shallow water. We know the water is shallow. The SRME cannot work very well. But the IPC can give the much better model. So with that model after saturation, we can see the multiple getting lights perfectly removed. And from the velocity spectrum, we can see here we can see some low velocity. It's because it's the multiple short period. But after this one removed, we can see the gather flat, and the island is much better focusing. And this is also the very good evidence about the successful of the removed multiple. Yeah. And this is also our daily work, part of our daily work. We're picking the velocity. We have different ways to get the velocity. This is one of the way. Yeah. Okay. So later we will show another. This is the SRME removed multiple, and this one is another example about the streamer. Actually, this is in Asia, this streamer project. And this is the initial project. I chose this slide because it's easy to understand and to convince that because we have the fault here, yeah. But so this is the initial velocity model, and this is the initial velocity model overlap with the initial depth migration. We can see this from the seismic. We can see there are faults, there are the reflectors, but the velocity is very smooth. We cannot see the trend very clear. But with the after back applied, we can see this follow the velocity. We can see this discontinuity. We can see the fault. And when we overlap the velocity with the seismic, we can see this the perfectly match. Especially this part very shallow. So this is a very good example to show after by work or not, because the photo, the slides will tell it's good or not. But after by also have its own limitation. First is the data quality and also have the age effect. So we can see that in the middle of the section, they're very sharp and they can match very, very well with the seismic. But in here, we can see this end. And actually, the velocity should be constant, but they cannot do the very good work because it's data-driven, and in the edge of the section is a low fold. So the light information is not so accurate. It's happened almost everywhere in the seismic exploration. Velocity model building has the same trending, and the image also. So the stack section in the edge is also less reliable. Next one, we show another examples. Okay, this is the afterby with the North Sea. It's open project. Actually, this I think with done acquisition by Qiao Departemen. Yeah, and this very interesting. Next slide will show the initial velocity model. Yeah, this initial velocity model is smooth, and this the slice depth slice, 3,800. Yeah, so initial one we can see this very smooth, and here is much more smooth. We cannot see the details, and we apply the 5 Hz afterby. We can see the reflectors, and from the slides we can see the boundary. Yeah, and we can increase 80 Hz, so you can see more details. More details show up, and the slides shows more details also. Yeah, and we can increase to 25 Hz, so you can see from the slides much more details shows up. Yeah, on the section also, even here we can see some detail like the reflectors. So as the velocity become more details, the velocity also can be can tell part of the water geology background. So we compare with the initial in nothing, and final 25 Hz. So you can see the huge difference. So a very successful acquisition can give a good input for the velocity model building. And if we can generate a velocity like this one, we have much more confidence. And this is the section with initial depth migration. Yeah, this one is after, with the afterlight. So we can see after afterlight, the reflector is much sharper, and the small falls we can see also. But before it's very hard to see this one. Yeah. So this is the power of velocity model building, and also we overlay the seismic and with the velocity, we can see there's a good high. Yeah. And even with zoom in, we can see the more details. It's the more abnormal geobodies. The velocity not also match. Yeah, this part. Yeah, it's a boundary about the reflector, so the velocity follows also. Shallow part also follow, and shows more details. It's totally data-driven. Yeah, it's very funny. And this is the afterby with the time slide and depth slide, so you can see the details. Yeah, so this is a boundary, and these other details. It's overlap with the seismic, so you can see it's perfect match. Yeah. So velocity and the seismic, they tell the same thing. And also we can, because conventional acquisition, we know we have the low cut. Even the low frequency repeater, maybe we start 1.5 Hz, and the acquisition in the streamer also have low cut because there's some very low frequency noise. We cannot image very well. So in the spectrum, we can see this the shot for the low frequency part. But with the FWI imaging, we can use the velocity information to generate the image. So we can see in the low frequency part, it's a very good input. So the section also looks different. The low frequency is much more rich. So we can see kind of the high resolution and the more stable result. Next one is another slice with different project also. There is the depth slice. This is the seismic, and this is initial velocity. This is velocity after afterby, and this is overlay. So you can see there are very good match, velocity and the seismic. So this is much more smart processing, and I think this is the future. It's already can be okay to work in the offshore data, both streamer and OBN. But the onshore data we're still trying. some product is okay, but not always success. It's much more complex and challenging. Next slide, we show another example about the streamer processing. Yeah, this is also in the complex structure. So this the conventional processing. We can see the deep part is very difficult to see the overthrust force. And from the reprocessing with the accurate velocity model building, so we can see the structure like this one. Yeah, overthrust force. It's very funny also. Yeah. So geophysics is very funny. It's interesting work. Another example is about the processing and the reprocessing. Did not show up. Yeah, this also the conventional processing. We can see the reflector, but it's the limited information. It's narrow bandwidth. With the broadband processing, we can see the much more rich information, and the small geo bodies is much more clear. The processing sequence. Actually, the processing sequence, this is the conventional depth migration, cohort. This is also cohort. Yeah, both cohort. But the velocity model different, and also the conventional processing different. I think the key is about the deghosting. Conventional deghosting not so good. Okay, last one. I take another 2-3 minutes to introduce something more interesting. Yeah, because now all the section we see here, we call this the conventional seismic. We call this the P view. P view. Yeah, we learn about the geophysics. We know the shear view and the P view. And before all the section we see the P view only. Yeah, P view going down and the P view going up. But except P view, we know also have shear view. So shear view normally is happen during even the argon and dynamite. They will generate both P view and shear view. But conventionally, we target on P view only. But shear view, we can use that one also. So actually, OBN is have 4 components. We have P view and also shear view. So sometimes OBN can processing the downgoing P view, upgoing shear view. We call it PS view. But for the onshore, we have something more interesting. We can use the shear view vibrator. So we can generate the source view directly. And recording also shear view. So we call it the SS. So if there is 3D, we can have the 3D and the net component is in total. It's very interesting. But first we want to see some. We do not want to talk more details about the theory. We will show some section. So this is the section, yeah. This is the section we see. We call it PP. Downgoing P, upgoing P. And actually this is the Qiao gas cloud here. So we can see this, the image looks okay, but in here is wiped out. So is that real or not? Because our seismic we do, except this morning by you guys, they say the VSP, we can call it Bawah seismic. Others, by Qiao and me, give the presentation about acquisition. It's all about surface seismic. Surface seismic has its own limitation. So if with the PP with conventionally, the section we got is like this one. But it's not real. Unless we do this one, we can know. Yeah? So with the P, and the downgoing P, upgoing with S, with the similar with the OBN, we can got the PS. PS, we can see this the wipeout it becomes smaller. Yeah, wipeout becomes smaller, but still this gas cloud in here, so affect the violet. So this one got better image, but not very good. So and here this the PS similar with OBN, but SP, downgoing with S, upgoing with P. So you can see it's also better than the PP, but similar with the PS, not very good. So later we can downgoing with S, upgoing with S. So you can see the totally different image about this one. Yeah, because the shear view cannot transfer during the gas cloud. So the information from the shear view is not affected by the gas cloud. So this we can see the kind of the real structure about the subsurface. Yeah, and this the isolated SH is another direction. So this photo I want to tell. So the subsurface is very interesting, and our current industry have some limitation. In the future, I think the nodal system is the future, and also the multi-component should be the future. So in the share view, we should do more study and maybe give us another view about the subsurface. Yeah. And this one, the next slide shows about the detail theory, but too boring to tell the details. And if you are interested, you can take a photo and analyze this one. It'll be very funny and very complex. Yeah. And this is another example. So it's much simple. Yeah? We call it PP and SS. So you can see PP here. There's a pull-down effect by the gas cloud. It totally wipe out. Here also it become artificial. Low frequencies, run amplitude is not real. And with the SS, we can see it's a beautiful anticline. Yeah. Okay. That's all I want to show now, and also time already up. Sorry, yeah. So any question, we're open to discuss, yeah. Yeah, please.
In the conventional seismic data processing, we often use deconvolution to further broaden our frequency band, but I didn't see that in your general seismic processing workflow here for OBN. So I was wondering if it's because the OBN has satisfied the broad frequency, therefore you don't need to further broaden the frequency, or can you still apply deconvolutions to further broaden the frequency data? Thank you.
Actually, it's a very good question. But actually, I have a lot of slides I want to discuss. But because of the time limitation, I cannot go to the very details. OBN is a very good question, and I think it's very useful in the industry. And for the frequency band, we call the recording frequency. And after that one, as you mentioned, we can apply the deconvolution to sharp the wavelet, and so we can have a higher resolution. But this deconvolution is totally different with the deghosting. The ghosting is a kind of short period multiple, and the deconvolution we sharpen the wavelet. So this have the similar result, but the theory is totally different. And the OBN, because we deploy the nodes on the water bottom, so this we can assume this can get the wilder and broader band. But this ghost also very heavy. So we have to apply the very successful deghosting to remove the receiver side ghosting. Otherwise, the frequency band is very narrow. With the proper deghosting, so the notch effect is based on the water depths, which we call it ghost, can be limited. And after that one, so the spectrum about the seismic will be flattened. And actually the ghost normally have two at least. In the high frequency part, it's related with the water depths, maybe sometime around 100, sometime 80, related with the short and receiver depths. That's one. Another one more important is around 0. 0 hertz is the most strong ghost, both south side and receiver side. So the deghosting is the key. Why the conventional processing we showed is the conventional and the new one is very different, because the key is the deghost. The deghost the notch can be eliminated in the high frequency, and the most important is the low frequency, around 0 hertz. So for the OBN, actually we target about deghosting more than the deconvolution.
So if I can paraphrase and understand your answer correctly, so you still basically use the deconvolutions, but only for deghosting. Is that correct?
No, deghost we call the deghosting. It's different method with the deconvolution.
Okay, so you don't use deconvolutions at all?
No, deconvolution can be the last stage, but in the early stage, deghosting is totally different. It's not deconvolution. Deghosting.
Okay. Okay, thank you.
Yeah, welcome.
Ada yang mau bertanya lagi?
Oke, makasih ya.
Okay. Okay, thank you Mr. Shan Yang and Mr. Chen Yang, Pak Sri Sadono, and also Mr. Yugang for today's lecture. The topics were highly relevant to our geophysics studies and truly opened our eyes to the complexities of marine acquisition. We truly appreciate the effort you each put into making the material so engaging and also inspiring. Let's give a big applause to our lecturer today. Baik, acara selanjutnya adalah penyerahan kenang-kenangan. As an act of our appreciation, we would like to present a gift as a symbol of our gratitude to our lecturers today. We invite Mr. Sri Sadono, Mr. Chen Yang, and Mr. Qiao Yang, and also Pak Wood. Please come to forward. Let's give another applause. Dengan adanya penyerahan kenang-kenangan ini, maka berakhirlah acara kita pada hari ini. Kami ucapkan terima kasih kepada para pembicara serta teman-teman semua yang sudah ikut dengan antusias dari awal. Ya, semoga apa yang disampaikan hari ini bisa bermanfaat dan memperluas wawasan kita semua. Okay, we as the Master of Ceremony would like to say a big thank you very much for the participant and also the attention. Wassalamualaikum warahmatullahi wabarakatuh. Shalom, Om Santi Santi Om, Namo Buddhaya, salam sejahtera dan salam kebajikan bagi kita semua.
Ada yang mau lulus? Ya? Bisa kerja di sana, Pak? Bisa nanti. Pak Chen Yang, ini